what is happening in the AI field recently. And I'm just going to give you what is what of all the different techniques. We are, so these days we are able to come up with these techniques because of the technological advances that we have made over the years. So we'll make use of that and see what is what of these techniques and how it is actually applied. So that will be covered in the first part of the session. Next, the second part of the session, I'll tell you how to build a machine learning model efficiently. Okay, efficiently because we have to adopt it or develop it or deploy it in even a low resource constrained environment, correct? You should be able to deploy it not only in a very big server which has CPUs and GPUs, you should also be able to deploy it in a resource constrained environment. So how to compress the model and deploy it efficiently. So that is the second part of the session that I'll cover after the break. To start with, I'll tell you what is neural networks and pattern recognition and why is it important. I think you would have heard this in the previous days of the FDPs, but still we'll just go through it in one slide, okay? What is neural network? Neural network is a network which mimics the activity of a brain. How does our brain work? We have several neurons which are connected through synapses. So here also in a neural network, it is a network made up of nodes. So the nodes will fire based upon the input. So the nodes are connected with connections. So the weights that represents the connection will tell you how to map the input with the output. So that is how a neural network actually mimics the brain activity. There are several different kinds of neural networks. You would have heard about CNN transformers in the last classes, right? Did you hear about CNNs? Okay. CNNs are mainly for image processing. We also have RNNs. Anybody knows what RNN is? Yeah, recurrent neural network. It is especially used whenever you have time series or sequential data. So your data is like, suppose we are building a weather monitoring system where you have to predict what is the weather on the 21st day based on the weather of the previous 20 days. So for the previous 20 days, you will have the timestamp and what the weather is. So based on that, you have to predict the weather for the 21st day. So in that case, you have to capture the past information also in the model. Past in the information in the sense, here the weather for the 20 days. Correct? So recurrent neural networks will help you do that. So that is a different kind of a network. So there are so many different networks which are used for different kinds of applications. CNNs and RNNs are the popularly used one these days. And applications of CNNs and RNNs and other neural networks are in so many fields, but especially in healthcare and finance. That is what should interest you as research scholars. If there is anybody who's trying to do research after PG, I think this should interest you more. Because, for example, in healthcare, in diagnostic imaging, so just looking at the CT image or looking at the MRI scan of a person, and along with that, you have the different parameters for the patient. They combine these two, and the doctor should be able to predict his prognosis. He should be able to give the prognosis, or he should be able to diagnose what the disease is. So that is a very interesting area, and it is going to be there for a long time, as long as the humans are going to be there on the earth, right? So that should interest you. And also finance. Everybody is going to make money. That is their ultimate goal. So finance is another sector where neural networks come into the picture and help us do a lot of predictions. So when you look at the stock market, you will also always be interested in where to invest and how much to invest. So that and all depends upon the past history. You have a lot of history data, historical data, right? So you can make use of that, build a model and use it for prediction. So then what is pattern recognition? Pattern recognition is gaining some knowledge from a model that is already built using the historical data. That is pattern recognition. So that is a pattern that will help you predict for the next timestamp. Okay. So here also there are different methods, statistical methods. In theory, this was published in 1950s, 60s and 70s, but it gained popularity because of the computational resources and the technological advances that we have made recently with the help of machine learning methods. There are different kinds of machine learning methods, supervised, unsupervised, semi-supervised, reinforcement learning, all these things come into the picture. Applications, security and marketing. Security, we have biometric systems everywhere, right? Wherever we go, even for marking the attendance, we have biometric systems. Retinal scans, fingerprint scan, even palm prints are there. So that involves image processing. So when you have a very big model, which takes in a lot of picture as input, it should be able to predict a good output. Here also, pattern recognition comes into the picture. It should identify whose fingerprint is. And also in marketing, we have Amazon, Swiggy, you get a lot of recommendations. Just by looking at one product, you are able to find out that there are so many products that are linked to this, which you will prefer to buy. So how do these companies make those recommendations? By analyzing the patterns in your behavior. So is it enough with the traditional neural networks that we have to do all these kinds of things? No. We are not satisfied. There are some limitations to the traditional neural networks. So these are the limitations. The first one is scalability issues. You have built a model, but is it scalable? Will you be able to deploy it anywhere in a system where there is going to be a lot of data? You have built a model for 100 samples of data, but is it scalable when you have 1,000 lines of data or 1,000 samples or 10,000 samples? If the data is going to increase, then what will happen to the neural network? It should learn a lot, right? Based on the input, it should be able to identify even the complex patterns that are there in the data. Then it becomes difficult. Then overfitting. Overfitting is a technical term that we use in neural network to say that the network has learned too much. Not the patterns that are there in the data, but it is fitting the pattern too clearly. So when it is going to see a unseen data, it will not be able to generalize it very well. Okay. For example, say that you have a model built to identify whether an object is an apple or not. Okay. So all the model has learned is that with the input, it has seen that when it is a red object, when it is a round object, and when it has like one leaf, that is how we usually draw apples, right? So when it looks at that and it will identify as an apple. Suddenly, when you just give an input to the same model with a green color apple, even though it is apple, it will not be able to identify because all it has learned is when it is red color, it is identified to be an apple. Okay, so here the model has learned too much. It has given too much importance to the color. So that is why it is not able to identify the green apple. So that is called as overfitting. Next is lack of depth. So you have built a model, you are giving an input, you got the output. Neural network is always called as a black box optimization because you do not know how the network has learned the patterns. So if you want to interpret that data, you interpret the outcome, you will not be able to do so very clearly. So that lack of depth of understanding the output is there. Okay. Next is manual feature engineering. So you need some domain expertise even to build a model. So I do not have a degree in medical science. So I cannot, if I want to build a model for diagnostic imaging, I should have some kind of a domain expertise, or I should take a help from a doctor or whoever is there in the medical field to even analyze or find out what features that I have to capture from the network. Correct? So that feature engineering or that domain expertise always is to be linked with the networks. Okay. So keeping this in mind, there were several theoretical breakthroughs that were made in the recent years, and the needs of the society has also grown. So what are those? So deep learning revolution has come up. Earlier, we had traditional neural networks with limited number of layers. Now we have started adding so many layers, and each layer also we have started adding so many neurons. So the networks have become deeper and also wider. So when you deploy it, you should have the computational resources to actually get the proper outcome. Okay. Next is demand for generalization. So if you build a model for some purpose, will you be able to gain some knowledge from the network so that it can be applied to a new problem. For the new problem, you don't have to train the neural network from scratch. Using the knowledge that you have gained for this task, will you be able to adopt it for a newer task? So that is the need for generalization. So that is a growing need in the society. Need for interpretability. As I told you earlier, you have the outcome, but will you be able to interpret it better? Will I just look at the AI's output and will I be able to make sense? That is the question. Interdisciplinary influence. So we have physical sciences, right? We have energy-based models. Those who are studying physics, you might know we have energy-based models, right? We have computer science algorithms. Will you be able to merge both? You have certain concepts in chemistry. You have algorithms in computer science. Will you be able to merge both? Will you be able to come up with a new algorithm which is based on the physical sciences? So that kind of interdisciplinary influence is also needed in the society now. Then there is a global competition, which you already know. All the organizations and different nations are trying to compete with each other to come up in the AI revolution. Correct? So everybody is constantly competing with each other. So many different techniques have been evolving and you have to be adapted to every different technique if you want to survive. Obviously, whatever model you're going to build has to be adopted by the industry. Everything is commercialized. So you have to keep that also in mind whenever you're building a neural network model. And evolution of hardware. Nowadays, we have Google Colab. You have worked in Google Colab, right? You have TPUs, you have NVIDIA's GPUs, all these things. So hardware is also adapting to whatever algorithmic technical advances we are making. So combination of all these things has led to more and more techniques and algorithms that are developed for specific purposes. Okay? So that is what we are going to see today. So what are the advancements that are beyond the traditional neural networks? So we have generative adversarial networks. We have transformers. I think you had a session on transformers the first day. And explainable AI, transfer learning, federated learning, edge AI, and quantum AI. I'll tell you what is what of everything. Okay, I'm not going to go so much technical into each topic. Only for GAN, I'll be telling you the architecture. For all others, I'll tell you what is that technique and how it can be applied to research. Okay? So first is generative adversarial networks. Why is it called as generative adversarial networks? Because there are two types of models, mathematical models. One is called as a generative model. The other one is called as discriminative model. So far, what you have seen is discriminative models. Discriminative models are nothing but you have a point X, you have a point Y. You are trying to find a mapping between these points. That is how X is related to Y. So if you understand this distribution of f of x comma y, given a new x, you will be able to predict what the y is. So those kinds of models are called as discriminative models. Generative models are models where you have f of x comma y as usual, but it will be able to generate a new x. Given the distribution, it will find a new sample point x. So that is called as generative models. Okay. So using generative adversarial networks, you will be able to create a new sample image. For example, your ChatGPT. If you give a prompt that I need a text, you just give a text prompt that I need a image of a man walking his dog. Maybe ChatGPT will not give it because it is a language-based model. Other generative models are there, right? You have DeepSeek, you have other image-based generative models. How is it doing so? With the help, the background is the GAN network. It is able to generate a new picture because it has been trained to do so. How it is trained, we'll see. And why is it called as adversarial networks? Because this GAN involves, the GAN architecture involves two networks which work hand in hand but also oppose each other. One is trying to outsmart the other. That's how they learn the pattern in the data. And why is it called as networks? Because it involves deep neural networks. So this is the architecture for GAN. So as I told you, there are two different networks. One is called as a generator network. The other one is called as a discriminator network. Generator network is the one which will generate a image based on some random input. Okay. So for the initial iterations, the generator will not know what it is generating. It will just using some random input, it will just generate something, some squiggly picture. Okay. Suppose say that you're trying to build a model where you're trying to build a model. When you give a prompt or a text prompt, it has to generate a picture of a car. Say that is the model that you're going to build. So initially, this generated network will have no idea what a car is or how to generate a picture of a car. So all it will do is generate some squiggly picture. Okay. But this discriminator network, what it will do is it will be trained with both the real images, that is the car images, and also some fake images, just squiggly pictures, which is generated by the generated network. So this discriminator will know which is which. It will know if it is a real data or if it is a fake data. So discriminator's job is to discriminate, given an input, whether it is real or fake, whether it is a car image or not. So using that output, again, the generator network will train itself back to creating more car looking like pictures. Okay. Initially, for initial iterations, it will just draw squiggly pictures. But from the output of the discriminator network will tell the generator network, no, what you have generated is not a car, it is just a squiggly picture. Oh, the generator network will think that, okay, I'm wrong somewhere, so I have to correct it, and it will correct itself. And finally, as and when the iterations move on, it will be able to produce more car looking like pictures. At that one point, it will fool the discriminator because the generated image will look more like a car. The discriminator will not be able to tell whether it is a fake image generated by the generator or it is a real data that is coming from the training data set. So that's when your training would stop in GAN. From then on, the discriminator network is no longer needed. You have a well-trained generator network which will generate a picture of a car when a text prompt is given. Okay. How these networks learn is using the loss functions. You have the discriminator loss for discriminator network. You also have the generator loss for the generator network. These two are neural networks, any kind of neural network. Okay. This is a neural network of its own. This is a neural network of its own. What kind of a neural network? That depends upon what application you are trying to build the generator model for. If you want it for text to image, it will be text to image. If it is for picture to picture, it will be picture to picture. I'll show you the applications of GAN. So before that, the types of GAN. You have the vanilla GAN, which uses multi-layer perceptrons. Have you heard about multi-layer perceptrons? So basic neural networks are built on multi-layer perceptrons, just nodes where you have weights and connections, and based on the weights, the input will be converted into the output. Those are multi-layer perceptrons. So the original GAN started with the generator network and the discriminator network being with multi-layer perceptrons. Then came deep convolutional GAN, where convolutional networks were used instead of multi-layer perceptrons. Here the advantage is the network will be able to capture a lot of information from the input data. Then we had conditional GAN, where additional parameters can also be given. So this is like more like evolved version of DC GAN. Then you have super resolution GAN. Super resolution GAN is a GAN which will convert a low resolution image into a higher resolution image. Can you tell me one application where this can be used? Historical images. That's a very good example. Any other example? Suppose you are monitoring a CCTV. Okay, you have to identify a person from the CCTV image. Usually CCTV images are of low quality, right? You have a training data set in which you have higher resolution pictures of all the people in your organization. So from the CCTV camera's picture, you have to identify who that is. So you have a lower resolution image, you have a higher resolution image to match, but you cannot match it. So that's where the SR GAN comes into the picture. So it will be trained on different people's faces. So when a low resolution image is given, it will convert the same image into a higher resolution image. Then you will be able to match it properly. So this particular GAN is trained for this particular purpose. These are all some pre-trained GANs, which are freely available, which you can use and you can customize accordingly. Okay? And there is something called as a cycle GAN, which is used for image translation. Here, the input is also an image, output is also a image. Suppose you give a picture of a cat and you want to change it into a dog, it will do it because it is pre-trained that way. And you have different artists, right? You have Van Gogh, you have Degas, you have different kinds of artists from the 90s, 1800s, correct? So they have their unique style. So if you give one style of artwork, it will convert it to another style if you have trained the GAN that way. Okay? So these are some applications of GAN. So which is used to generate new data. The new data may be people faces or text or poems or songs. You have separate GPTs for getting music. Have you seen? If you just give lyrics, it will just put music to the lyrics and give you a song. So there are pre-trained GANs available in the internet. You can just search for it. And GAN is also used in game development, creation of characters. Suppose you are a game design engineer. You are asked to create an avatar for a new game. What do? You just use a 3D model, 3D development software. You create the face, you create the hands, you create the torso, you create the legs, and assign the input script where you assign how the object actually walks. If you're designing a human walks in a certain way. If you're designing a robot, the robot walks in a certain way. Correct? So the movement also you will be able to design. But that is a very tedious process and it is a very long process. Suppose you train a GAN where you just give a text input. That input script will have what kind of object you want to create and what kind of motion you want to associate with the object. It will automatically create an avatar and it will give you the motion also. So you can pre-train a GAN that way. So that is one of the application. Next is prediction of next frame in video. You have a video, you have a set of images, you want to predict what the next image will be. Then you can use pre-trained GAN for that. And data augmentation is a very important application of GAN. Say you have a neural network which is going to discriminate cats and dogs. Okay, but you have only limited data set of cats and dogs. Now you want to augment the data. So what do? You have enough pictures, say you have only 10 pictures of cat. What you do is you just apply some basic operation. You flip the image of a cat, you rotate the image of the cat slightly like 45 degrees and make it a new image. That is, you augment the data. So from 10 samples of cat images, you will be able to get at least 100 different images just by flipping, just by rotating. So that is data augmentation. So here using GAN, you just give a prompt and tell the GAN that you want some more cat pictures. It will just produce and give you some cat pictures, which you can add it to your data set and you can use it to for classification in your model. Okay. Next is forensics, age progression. This you might have seen in TV and other series, web series and movies. Like you give a picture of a small boy or a small girl and just give it to a computer and it will give you how, it will show how the person will look like when the age progresses. Okay, so this is very important application in forensics. If anybody is interested in GAN and doing research, you can just look into this. It's a very, very important and upcoming application. So that's all about GANs. Next is explainable AI. So you have AI, you should be able to interpret the output of AI. Correct? So that is called as explainable AI. So explainable AI refers to a set of techniques, methods, and tools that make the decisions and predictions of AI systems understandable and interpretable to humans. Suppose you are building a medical image AI system where it will take input of CT scans, some blood parameters of the patient, and also MRI scan, and it will produce a discharge summary with charts and figures, or it will tell you what caused what. Okay, to understand that, you should have a knowledge of how that actual system works, how that mapping is done from the input to the output. So that is where explainable AI comes into the picture. There are some predefined techniques that you can use to interpret the output. Okay. So why is explainable AI important? It is because without that, there is no accountability. So for example, say that there is a big organization which is building a AI model, say using GAN. to identify a person. Okay. The client is coming to the organization and asking them to hold a meeting and explain the outcome. They are asking why this model has predicted this. So without that interpretation, without the mapping of the input and the output, the company people will not be able to explain it to the client, right? They should be able to explain it so that they will not get into some legal trouble. So that explainability is very, very important. Otherwise, you will be held accountable. Next is debugging and improvement. Only if you know how something works, you will be able to find out whether there is an error in the system or not. Without that knowledge, you will not know whether the output is error or correct information. Correct? So that explainability here also comes into the picture because the model that you are going to build should be error-free. Okay? So others and all is self-explanatory. So the key concepts that comes with explainable AI is interpretability, transparency, so that you already know. So what is post hoc explanation? Post hoc explanation is you have built a model. After building the model, you have predicted something. Based on the prediction, you are explaining the mapping of input and the output. Okay, not during training of the neural network. Okay, so that is post hoc explanations. Then what is local versus global explanation? Local versus global explanation is, say that you are building a neural network model to look at a customer's loan application and predict whether that loan application can be approved or rejected. Okay, say that you are working in a bank and you are building a model for this kind of a application. You have built the model. It looks at one customer's application and it has, say, assume that it has rejected the application. But you should be able to tell the customer why this has been rejected, right? So for this specific application, what caused the model to give this outcome? That is called as local explanation. Global explanation is, in general, looking at all the applications that the bank has received, why this outcome has happened. That is global explanation. Why the model is performing this way, that interpretation is called as global information. For one specific input, why the model has acted this way is the local explanation. Okay. Next is counterfactual explanations. You always want to know what if scenario answers, right? What if I change a parameter in the input this way so that the outcome is the other way? So that what if scenario answers are important whenever you are building a neural network model. So that is called as counterfactual explanations. So all these techniques come under explainable AI. Yeah. So before, this is a picture which shows the importance of explainable AI. So the top you have the traditional neural network where you have a image classification or something related to image processing. You have the input image data. You have the neural network. The network is learning some mapping from the input to the output, but the user is not able to understand what that mapping is. But in explainable AI, so this is included. Others are the same. You have the training data. You have the network. It is learning something, but you will have an explainable interface, meaning it will just produce an output which is understandable by humans. Maybe it is a chart. Maybe it is a importance of, it is listing out the importance of features. If you have 10 different features in your input data, which is contributing to the output, which input feature has contributed more? Which is the second important feature? Which is the third important features? Likewise, you can list out the features ranking. Then you'll be able to understand the mapping better. Correct? So that is one way of explanation. Giving it as a chart is one way of explanation. Giving it as a graph is one way of explanation. So your explainable AI model will give you only this. There are different explainable models called as LIME, SHAP. So all this will give you some kind of a interpretable output. Okay. So what are the challenges in explainable AI? The trade-off between accuracy and interpretability. You have to understand when the explanation is needed and when you have to compromise on the explanation and when you have to concentrate only on the model's output. You want accuracy or you want explainability. So that trade-off as a designer of the model you should have. that is dependent on the application. Okay, so if it is a loan processing application, explainability is more advantageous than the actual outcome itself. Whereas you are building a model for a nuclear power plant, there, instead of explainability, accuracy is very, very important. Why do you have to have this trade-off? Because you are working in a neural network, right? If you concentrate more on the accuracy, you will have more connections in the network. You will be able to capture the complex patterns. If you are concentrating on interpretability, then you have certain number of connections where interpretability is important. So accordingly, you have to build the network. Okay. Next is scalability, which you already know. Then human understanding. So suppose that we'll take the same example of medical image diagnosis. So you have the CT images, you have the parameters of the patient, you have built a model, the output model is giving you some kind of a output. The output is given to a doctor and also a lab assistant or lab technician who is there in the lab. The model's output is the same. It is the same graph, it is the same content and everything. But the doctor will be able to interpret it differently and the lab technician will interpret it differently. But it is a common output. So that is a disadvantage, right? So according to the user, you have to customize the output. So that is also one of the important research problems that you can analyze. Next is evaluation of application explanations, meaning there is no universal metric to evaluate the explainable AI's output. All it does is, this is the important feature that it has contributed to the outcome. This is the second important feature that has contributed to the outcome. But how? You do not know. How will you measure it? You do not know. Okay. Based on only simple statistics, you will be able to identify. Other than that, there is no universal metrics to analyze this. Okay. Applications, there are different fields in which you can use explainable AI, healthcare, finance, autonomous vehicles, criminal justice. Where in criminal justice can you use explainable AI? Any idea? Surveillance. Just like bank approval process, loan approval process, you have parole boards, right? When accused is sent to a parole board meeting, the parole board will decide whether, based on his behavior in the jail, he will be decided whether he should be released on bail or he should be kept in prison. So in those cases, explainability is really, really important. You have to understand the features of how he behaved in the prison all through the years, and you should rank what is his advantage or why you should keep him in the prison or why you should give him bail. So that is also a very important upcoming area where you can concentrate on research. But data, I don't know whether it will be available or not, but it is an important research problem. Okay? If you can find data, I think you should take up this. It will be interesting also. And customer service, you have Amazon, Flipkart, where they make recommendations. So they should be able to analyze why this recommendation has been made to this customer. Okay? They have to make it in their report, right? So explainable AI comes in handy. Next topic is transfer learning. So what is transfer learning is, you have built a neural network model. You have gained some knowledge. Can you use the knowledge gained from this network for a completely different task, for some other task? It should be a related task, but it is a different task. Because for the second task, you don't have to train the entire neural network model from scratch. Correct? You can just gain some knowledge and you can apply it to a newer problem. So that is called as transfer learning. So this also gained popularity in the mid 2015s, I think 2010s, 2015 or 16, I think. Okay. So ability to reuse existing models and their knowledge for newer problems is transfer learning. So the model developed for one task is reused as a starting point for a model on a second related task. So I keep saying knowledge, right? What is that knowledge? What is that you are going to reuse from a neural network? What are you learning from a neural network? What does a neural network learn? The neural network has nodes, it has connections, and you give the input data. it will map you, it knows the output data, it will map the input to the output, and it will keep learning. If it makes a mistake, it will keep learning. So what is it actually gaining as knowledge? The weights in the network. That is one parameter which it actually learns. How much of this input contributes to the output? That is the weight, right? How much of the next input contributes to the output? So the weight is the important thing which a neural network learns. So if you are building a newer neural network model, you have to train it from scratch. Again, you will be learning the same weights for that particular input data. If there is some way where you can use the weights that you have already calculated for some task, for example, that task may be identifying whether a given picture has a cat or not. Okay? Can you apply it to another model where you have to identify whether the given picture is a dog or not? Okay, for cat, you will be training it with cat images. For dog, you have to train it with dog images. But that is going to be a tedious process, right? You have to have a very big data set of having pictures with the dogs. You have to train the network. You have to store the weights and finally use it for prediction. Instead, you have already have a model which is doing the classification of cats. It has trained and it has some weights. Maybe it is closely related to this problem. So I can use the same weights in the neural network and just adjust the model so that it will classify a dog. Okay, that is called as transfer learning. Okay. So features, weights, and representations are the knowledge that we are talking about here. So if you look at the transfer learning architecture, this is a neural network architecture without for some task. So these are the layers in the network. These are the final layers in the network. This is the newer task. What you are doing is you are keeping all these layers fixed. Up there you are just copying, but here you are just changing the final few layers so that it is customized for the target task. This is transfer learning. So when you are training this target network, you will keep all the weights fixed. You will not train it again. Only these weights you will calculate. Got it? So how to implement transfer learning? First, you have to choose a pre-trained model from where you're going to gain knowledge. That model can be an image model or a text model, depending upon what kind of application you are taking. Then you have to prepare the target data set because you have to adjust your target data set with the source task, right? So you have to pre-process your target data set accordingly. Then feature extraction, where you freeze all the layers of the source model so that it is not trainable. You're just keeping the weights as such and train only the new layers that you have added in the target model. Then fine tuning, this is optional. You can customize further. And finally, you evaluate the model and deploy it to the machine. Okay. There are different types of transfer learning. One is inductive transfer learning, where the source and the target tasks are different, but the domains are similar. Example is using a model trained on general object recognition, which is the source task. You can use the model for medical image classification. Here it is object recognition is a task. Here it is image classification is a task. But the domain is image processing. Okay. Next is transductive transfer learning. Here the source and the target tasks are the same, but the domains are different. Example, adapting a sentiment analysis model trained on movie reviews to product reviews. All you're doing is what movie is best. Based on all the user reviews, you are finding out whether this movie is good or likable or lovable. That is a sentiment analysis you are doing from the reviews. What you are applying it to is same input is reviews, but it is product reviews. Whether that product is good or bad. Okay? That is transductive transfer learning. Next is unsupervised transfer learning, which is where the source and the target tasks are both unsupervised tasks. Unsupervised task in the sense, do you know what supervised and unsupervised learning is? Not labeled. Okay, both the tasks are not labeled. So you're involving clustering. So you use one pre-trained model which does clustering for another model which also does clustering. So these are the advantages and challenges of transfer learning. So reduce the training time because you have gained the knowledge from the source task. So you are simply reusing it. So that will lead to improved performance and resource efficiency. You are not using so much computational power, both memory and computation. You are not again recalculating all the weights and storing it. You are just simply extracting the knowledge from the source task. Challenges, there might be domain mismatch. So whatever your pre-trained model you have chosen might not work with the target task. So when you are choosing a model, you have to be very, very careful. And there is a problem of overfitting. Also, you have to select model and task specificity. Suppose the target task that you want to apply it for needs some customization. So you keep on customizing the newer model. Then what is the purpose of transfer learning? The purpose of transfer learning is using some knowledge from the source task to the target task. If you customize the target task too much, then the transfer learning part becomes moot. Correct? So next is federated learning. Federated learning is, look at this picture. Usually when you train a neural network, the data will be in the machine. The model will be in the same machine. The calculated weights that'll come out of training will also be stored in the same machine. Okay, but federated learning is a decentralized approach where you have different machines throughout a city. For example, say that a bank has a server and there are different branches of the bank all over the city. In every bank, there is knowledge about that bank's customers. Say that you are developing a neural network model which will analyze the customer's behavior and give some output. What we usually do in traditional neural network is that in the bank's server, main server, will transfer all the data from the individual branches. The server will have the model, it will calculate the weights and it will just give the outcome to all the different branches. But instead, in federated learning, what we do is instead of transferring the data to the server, we keep the data in the client branches itself. We give the model to the client branches. The model will be applied on the input data, produce the output, and it will be given to the customer. Only the weights of the model will be updated to the server. So using the updated weights, the model will also be updated and it will be given back to the clients whenever it is needed. So that is the picture which is shown here. So these are the client machines. This is the centralized server. You have, the first step is to initialize the model. You have to find out how many layers in the neural network you have, how many neurons in each layer to have. So you have to initialize the model. So once the model is initialized, the model is sent to all the client devices. The devices, the individual clients will have their own data. They'll apply their data on the models and calculate the weights, and the weights will be sent to the server. Based on the new weights, the model will be trained again. Meaning that it will be updated, not trained from scratch, but it will be updated. It will aggregate, the server will aggregate all the knowledge from the client using federated averaging. Okay. Then updated model will be sent back to the client for the next analysis purposes. This is federated learning. It's a decentralized approach. Okay. The challenges here is communication overhead. Every time the model is updated, it has to be sent back to the client. Every time the weights are updated in the client, it has to be sent back to the model. So this has to involve a lot of network traffic, which is a communication overhead. Say that some branch is not able to communicate with the server, then that particular weight updation is lost in the network. Correct? So that and all is there. And non-IID data. Non-IID data is the data in the individual devices are independent or not independent of each other. They are related somehow. In that case, the weight updation will be wrong. Okay. And device heterogeneity. That is, the individual branches have different kinds of servers in different kinds of machines. One will have a CPU. Maybe the other branch is not that affordable. They'll have only low resource constrained devices, or the other branches might have a GPU. So there is device different. The difference in the computational power in the devices. That will also contribute to the model's output. Okay? And privacy risks are there. Even though the raw data is not shared through the network, you are still giving the weights. From that weights, if a hacker wants to get some data, they'll get the information from the weights and maybe they'll try to hack the model. Okay? And convergence issues, because if any one of the branches server goes down, then that weight will not be updated properly and convergence of the model will not happen. So next is Edge AI. What can you tell me about Edge AI? Anybody heard about this, Edge AI? Microsoft's? Oh, that is a search engine by Microsoft. That is Edge, but what is Edge AI? Again, we'll take the same bank application. You have different branches, right? What we do traditionally, we transfer all the data to the main server, and the main server is the one which is calculating the output and giving it to the individual branches. Till then, the branch has to wait. Correct? All the computation is done in the server. It involves network traffic. Maybe the analysis will take 1 or 2 days. Only then the individual branches will receive the result. We do not want that, right? We as humans always want results immediately. That is what we look for. So what do? You have a little bit of computational power in each of the branches. You process the data there itself and give the result immediately. That is Edge AI. Okay. See the picture here. This picture that is on the right will show you the traditional model where you have individual devices. Maybe the data is coming from a sensor. Maybe it is coming from an appliance. Maybe it is coming from some kind of a equipment. All the data is given to the server. The server is the one which processes all the data and gives the result back to the client. Whereas in Edge AI, you see that the appliance by itself has some kind of a computing power. It processes the data and gives the result in real time. Can you tell me one example of Edge AI device? How many of you are wearing smartwatches? If you're wearing a smartwatch, is it an Edge AI? Does it have an Edge AI capability? Yes, it has, right? Some of the sensors in smartwatches now are able to detect ECGs, your blood pressure values. The sensor is getting the input from your own body. Are you able to see the results immediately? Yes. It is not going to a server and then calculation is done and you are getting the result the next day. Right? You are able to see it immediately. So that is the edge device where there is some computation, there is some memory, there is some processor in the watch which is doing the calculations and giving it back to you then and there. Okay? That is nothing but Edge AI. So this enables real-time data processing. It reduces latency. It improves privacy and also lower bandwidth usage. Okay? So ideal for applications that require fast and efficient decision making at the source of the data generation. Wherever the data is generated, you need the results immediately. Okay? So key techniques that enable Edge AI. So far we have seen neural networks which are really big and complex. The bigger the network is, the more weights it has to learn, the more patterns it has to analyze, the more memory it needs to store all the weights. But Edge AI, you have only limited computational power. So the smartwatch has limited amount of memory and limited amount of processing capability when compared to a GPU or a laptop. Correct? So whatever neural network model you are deploying in an edge device has to be efficient and it should be able to analyze the pattern but not use the memory so much. Am I right? So that's why the key technique that enables Edge AI is model compression. You compress the neural network model so that it can be deployable in a resource constrained environment. Also, if you are able to do specialized hardware, you can do specialized hardware and put it in the edge device. But this is out of our hardware is not part of the FDP topic, right? So we are concentrating on the software part, which is model compression. how to do model compression. There are two techniques that I'll discuss before our break, which relates to model compression. One is called as pruning. The other one is called as quantization. What is the meaning of the word pruning? Removing or cutting. Usually a gardener who's in charge of maintaining a beautiful park, what does he do? He just prunes all the bushes so that he'll make a beautiful swan shape or a peacock shape so that it'll attract people, right? You're also in neural network, you can prune the network so that it is compressed. The model size is reduced. What do you mean by pruning a neural network? What are you actually pruning? What does a neural network have? Does it have nodes? Does it have connections? What are you learning? The weights. If the weights are 0, what does it mean? The input is not contributing to the output. That particular input is not contributing to the output. Then what is the use of storing that weight? Correct? You can remove the weight. That particular connection you can just remove. Likewise, you can prune weights. You can also prune the nodes. If the node is producing an output as 0, in neural network, we have something called as activation functions. Have you heard about that? Each node will have an activation function. Activation function is nothing but a mathematical function. It will produce either 0 or 1 or any value between 0 and 1. If it produces 0, what is the use of having that node in the network? Just remove it. Okay? So you can prune weights, you can prune nodes in a neural network so that the model size is reduced. Or you can prune an entire layer. Suppose that layer, if all the neurons are producing 0 as output, what is the use of having that layer? You can remove the layer. Okay. Suppose you are having 4 layers in your neural network. You are getting 90% accuracy. You are running the same model again with 2 layers. You are getting 90% accuracy. What is the purpose of adding 2 more layers, right? So you can remove the layers. So that is what is called as pruning. Pruning is to reduce the size of the model by removing unnecessary or redundant parts such as weight, neurons, or entire layers. This is to create a smaller, faster, and more efficient model. Okay. So when to prune a neural network? Is it during training or after training? You have created a model successfully by training the model with some kind of a data set. Your model is ready now for working. Will you compress the model after after training or not? That is the second step, post-training pruning. Or you can choose to train a model at the same time pruning it. Okay, that will take more time actually. Okay, but it will result in an efficient network. Because train time pruning involves one of the objective as keeping the sparsity of the network in mind. It has to train as well as keep the model simple. Whereas post-training, you are not worrying about pruning for the first time. You have trained the model, you have built the model, you are seeing the output. Okay, after seeing the output, maybe you are choosing to prune the network or not. That is post-training pruning. So post-training pruning has 2 types, structured and unstructured pruning. Unstructured pruning is, example is this. Say that these are the model weights that you are learning. Okay, you are setting a threshold for the weight. Maybe if the weight is below 0.5, I do not need that node at all. I'm removing that or pruning that connection. So all the weights that are above 0.5 will be retained. All the weights that are below 0.5 will be made as 0 or it will be pruned. This is unstructured pruning because there is no structure in the output. Here I have just the weights, 2 of the weights have become 0. Here 2 of the weights have become 0, but in this position. So it does not have a particular pattern. Right? That is unstructured pruning. Yes. You're pruning entire structures, that is entire channels, filters, or layers. A complete layer in the neural network you are pruning. But if you have to do this kind of a pruning, you should have complete knowledge about what the application is and how it is working, right? One is magnitude-based pruning, where we just saw an example. Based on some threshold value, you choose to remove the weights in the network. Or gradient-based pruning. So when you use neural networks, you have something called as back propagation. That is how the network actually learns. Gradient is nothing but the first derivative. Correct? So based on the gradient information, you can prune. Or there is something called as lottery ticket hypothesis. This is a famous one, which is most used commonly used technique, which is nothing but you prune a network, get a subnetwork. You prune the network again by removing some other weights and you get a subnetwork. Likewise, you get different subnetworks. Whichever resembles closely to the original network's output, that you keep. That is the winning ticket. That is the lottery ticket. That is the subnetwork which has the lottery ticket. Okay? Thank you. Then you have something called as iterative pruning. Iterative pruning, the picture is shown here. So you have built a network. You evaluate the importance of the neurons or nodes in the network. You remove the least important neuron, then fine tune the model again, and you choose to prune again or not. If you're not satisfied with the output, you continue evaluating the importance of neurons, again remove the least important neuron. Likewise, this process continues until you're happy with the model's outcome. This is iteratively done. So it is called as iterative pruning. So global versus local pruning is local pruning. It proves each layer independently based on its own criteria. So every layer in the neural network will have some kind of a pruning criteria. So that pruning criteria is different for each layer. That is local pruning. Global pruning, you have a common pruning criteria for the entire network. For example, say that the weight has to be less than 0.5 to be pruned. That applies to all the weights in all the layers in the network. Whereas local pruning, for the first layer, maybe the weight should be less than 0.5. So the second layer, only if it is 0.3, I'm pruning, otherwise I'm keeping the weight. Third layer, maybe it is less than 0.2, then I'm pruning, otherwise I'm keeping the weight. So each layer has a different pruning criteria. So how to evaluate whether the pruned model works correctly or not? You can use any of these metrics. You can use the model accuracy or model size or computational time. So how much is the model producing as accuracy? If the original model produces 90% accuracy, and the pruned model produces 89% accuracy, and you're okay with that. You're compromising on the accuracy a little bit, but still you're getting a reduced model size. If you're okay with that model's performance, you can choose the pruned network. Okay. Model size. Model size here means the memory requirements. You are storing all the weights in the machine, right? So if the weight is, if the weight is a 5x5 matrix, for example, if 3 of the weights have been pruned, then you end up with a sparse matrix. If you are okay with that, you have the pruned network. If you are not okay, you continue pruning. Okay, so model size can also determine whether you are happy with pruning or not. Last one is computational time. Computational time may also refer to inference time. Inference time is the model is built, you are giving a new data to the model and you are predicting something. How much time is it taking to do this? That is called as inference time. But is inference time the right metric to evaluate a pruned model? I would say no. The number of floating point operations that a model uses is the actual metric that you have to use, because the floating point operations is not dependent on the model as such, the underlying hardware. Correct? Whereas the inference time relies on the underlying hardware. If the same model is run in a machine with a GPU, that will give you the result in a second's time. Whereas the same model is run in a machine without a GPU, that will take a little bit more time to get. So the inference time is not a good metric. But the number of floating point operation is not going to change based on the hardware. It depends on the design of the model itself. So that is why it is a very good, important metric. Okay. The last compression methodology is quantization. So this is how a neural network model works mathematically. So this X represents the input. This is a node in the neural network, which is nothing but a mathematical function, which is summation. And you have a node which is called as activation function. It is just some mathematical function applied to the input to get the output. Here the mathematical input function is nothing but W into X plus B. W representing the weights into X. So it is X1 into W1, X2 into W2, Xn into Wn plus one constant which is called as bias. So that is the output of this model, which is Y cap. Okay. If you see here, there is matrix multiplication involved, right? All the weights are stored as a matrix. All the input values are stored as a matrix. Matrix multiplication is a complex operation in computer science, especially if it involves floating point digits. Floating point is with decimal points, right? Because storing a floating point in the computer hardware is much difficult than storing an integer. So quantization is a process where you try to or approximate storing the weights which are originally in floating point as a integer values. For example, if the weight is 2.03, you just store it as 2. That's the meaning. That's all. Instead of floating point, you store it as integers. But you will compromise on the accuracy of the model. But if for some application, if you are okay with that model's accuracy, then you can go for quantization to reduce the size of the model. Okay. So that is what is explained here. So quantization is the process of approximating a neural network that uses floating point to lower bit with integers. So this significantly reduces memory and also the computational cost. So there are different kinds of quantization. You have uniform quantization where you map the floating point values to integers using a linear scaling function. For example, say that the weights are in the range -1 to 1. You have to store it as an integer. Integer in computer science has a range -128 to 127, meaning that if the weight value is -1.0, you are mapping it as -128. If the weight is 1.0, you are mapping it to 127. All the values that are in between are mapped to values in between in the integer range. Okay, using some linear scaling function. If you are using a non-linear function like an algorithmic quantization, logarithmic quantization, then it is called as non-uniform quantization. So this, I think we'll skip. This is too technical. Types of quantization, you have different types of quantization. So this is similar. These two are similar to the pruning techniques. When to prune? We had during training, we pruned, or you can choose to prune after training. This is the same thing. You can choose to quantize during training, or you can choose to quantize post-training. That is quantization aware training and post-training quantization. Okay, the same thing. Static and dynamic is here both the weights and activations are quantized before building the model. Whereas here it is done one by one. First you are quantizing the weight and then the activations. Okay. So challenges in quantization are there might be a loss in accuracy of the model because you are storing all the floating point as integers. You need special hardwares which supports this kind of a representation and calibration. Suppose you have built a model based on some input data which is already calibrated to floating point. Now you are ending up storing the model as a model with integer values. Then there is a calibration overhead. Okay. So we have seen different compression techniques, but we have seen that it is affecting the accuracy of the model. So how do you balance both? You still have to have a good accuracy. Also, the model should be of smaller size. So how do we compensate? So that is what we're going to see post break. And I ask you that if it is too technical for you, just let me know during the break. I'll keep it as simple as possible. But if you're okay with this space, I shall continue. Okay. Now we have FD. We'll be back by 11:50. Parents will the reaction.
So, dear participants, kindly settle down. We'll resume the session. I request ma'am to come and take over the session.
Welcome back. So we'll move on to the second portion of the session. So as I told you, so there should be a good trade-off between the neural networks model size and the model's performance. Okay. So how do we do that? So that is done using model tuning. Okay. So in that, I'll be concentrating on hyperparameter tuning. I'll tell you what a hyperparameter is and what are all the algorithms or techniques that you can apply to tune the hyperparameters in such a way that you end up with a good model of reduced size as well as a good performance. Okay. So this is where we are. Say that you are building a model, neural network model. You have collected the data. You have defined the problem statement for what you are going to build the model. And you have built the model. Okay, the model is working fine. But should you stop here? Not necessarily. You can fine tune the model. You can either reduce the model's complexity with the same performance, or you can go for maximizing the performance with additional complexity. Whatever you want to do, it is up to you based on the application that you have. Okay. So the purpose of fine tuning is to ensure that the model performs its best. The process is you adjust various elements of the model to achieve optimal results. Most of the time, you will not end up with the optimal solution. You have to be satisfied with a near optimal solution. Okay. So tuning the model means that it is an experimental process of finding optimal values of hyperparameters of the model. Okay. I'll tell you what hyperparameter is. So if you want to look at the difference between model's parameter and hyperparameter, model parameter is the one that you learn from the model, that the model actually learns. So when we are talking about neural networks, you have the input data, you have the class labels, right? In supervised learning, you have the labels for the data. The neural network model that you are building actually maps the input with the output and tries to find the weights and the connections. Correct? So the weight is learned from the or learned by the model. So that is a parameter of the model. Whereas a hyperparameter is a one which is not learnt by the model, but you set values for it before training the model itself. That is how well or how fast a model should learn or how slow a model should learn. Okay. So for example, there is a hyperparameter called as, I'll tell you, learning rate. Learning rate of a model will determine how fast the model actually learns. Okay. If you set it to a smaller value, 0.01, it will update the weights very slowly and it will keep learning for a longer time. So it means that the training time is more. If you set the learning rate as 0.01 before the start of the training, the model will learn fast. It will update the weights more. Every iteration, suppose the weight value is 1 for the first iteration. It will add maybe 1.1. Then it will move to 1.2. Then it will move to 1.3. If you set a learning rate, which is 0.1. Suppose the learning rate is 0.01. For every iteration, it will do as 1.01, 1.02, 1.03, meaning that it is learning slowly. It will updating the weight slowly. It is learning slowly. Whereas when the learning rate value is more, it will learn faster. The training time will be less. So these hyperparameters are some of the parameters of the model which is not learned during the training process, but you have to set before training, starting the training process. Okay. So by controlling the values for hyperparameters, you can end up with a model which is perfect or near perfect. I should say near perfect because it will have a reduced complexity, but it will also have a good performance. Okay. One more example for a hyperparameter is the number of clusters in k-means algorithm. Or have you heard about k-means algorithm? In unsupervised learning, where you set the value of k. K will determine how many clusters you are going to form. That is not learnt during training. Before the start of training, you will say that I want to group this input data into 3 clusters. Then the model will group the entire data into 3. Suppose you set the k value as 4. It will try to group all the input data into 4 different clusters. So that is one hyperparameter example, the number of clusters k, which you set before the training process. Okay. Likewise, based on the model or the technique that you have, there are different kinds of hyperparameters. So how to set the values for this hyperparameters is what we are going to see. Usually it is set based on some expertise. Already you have some, suppose you are, say that you are trying to do some image classification. You are building a neural network model. For this kind of a classification, if I set the learning rate of 0.01, maybe the model will work better. That is what you have understood from the literature survey. So what will you do? You will just set the learning rate as 0.01. But what are your options? You can try different values for the learning rate and find out which suits your input variable best. Only if you have time for tuning. If you do not have time for tuning, you go for whatever you studied from the literature. If you have time for model tuning, and if you really want to tune the model, then you can try different values for the different learning rates. Keep building the model again and again for the different values. You have the final outputs of model, different model outputs. You choose one model output which best suits you. For example, set the learning rate as 0.01. Do the training fully, you have one model. Set the learning rate as 0.02, do the model, and you see the output. Set the learning rate as 0.03, build the model, see the output. Now you have 3 different models to choose from. Whichever has the best performance, you keep that learning rate and finalize your model. That is what hyperparameter tuning means. Okay. So you can tune hyperparameters for some algorithms that you are using, or you can also tune hyperparameters for the models you are building. So if you tune the hyperparameter of the models, means that you are doing a neural network architecture search. Meaning, what are the hyperparameters for a neural network? Say that I'm asking you to build a neural network now. I'm asking you to write a code. How will you build? You'll input all the Python packages. You have to decide on how many layers that you want in your model. You have to decide on how many neurons to keep in each model. These are all not learned, right? Before starting the model, you are setting all these values. So these are all some hyperparameters. So based on how many layers you have, how many neurons in each layer you have, the model complexity differs. So you are actually searching for a good architecture for your model. So that is why it is called a neural architecture search. Okay. So this is what is the tuning process. So you have, see this picture. You have the data, which you classify into training data, some validation data. You have built the model, but you do not know whether this model is perfect or not. So what you do is you take different hyperparameters that belong to this model, try different values for the hyperparameters, and keep building new models again and again. Finally, when you are happy with whatever models performances, you finalize that model as your final model. That is the tuning process. So this is what you actually do in this. You have the hyperparameters. For example, say that you are building a neural network model. You have number of layers as a hyperparameter, number of neurons in each layer as a hyperparameter, and learning rate as a hyperparameter. I've chosen number of layers as 3, number of neurons in each layer as 512, learning rate as 0.1. I have built a model. The model has learned its weights and say that the accuracy is 85%. Now I'm changing the hyperparameter values manually. Number of layers, I'm setting it as 3. Number of neurons, I've increased from 512 to 1024. Learning rate, I've decreased to 0.01. With these values, I've built a model. Okay? Maybe that model is giving an 80% accuracy. Likewise, I've changed the number of hyperparameters again, and I'm building a new model. Maybe it is producing a 92% accuracy. So which is the best model? The last one. If you're looking at only the model accuracy, the last one is the best. But see the number of layers. How many layers do you have? 5 when compared to 3 here. How many neurons you have? Here you have number of layers is 5, but the number of neurons in each layer is only 256 when compared to 512 here. Okay, so there is a change in the model architecture itself, but still it is producing a good score, good accuracy score. So it means that this set of hyperparameters is the best for your model. Okay, so this entire process is called as hyperparameter tuning. Trying out different values for the hyperparameters, finding out the accuracy and choosing the best model. That's the one-line explanation of that. So how do you tune a model? What do you need? You can either choose to tune the model manually by just changing all the parameters one by one manually in your code, try different models and finally select a best model. Or you can automate this entire process. What you have to do is you have to define the domain for the number of layers. Maybe the number of layers can be 1, 2, 3, 4. Those are my choices. Number of neurons can be 256, 512, 1024. Maybe those 3 are my choices. Okay. Now I define a space of hyperparameter values. I draw a 2D graph. One with number of layers in the x-axis, one with number of neurons in the layer in the y-axis. Now I pick one value in the 2D space. Meaning, maybe I said number of values as 2, number of neurons in each layer as 512. Try the model. Maybe I said number of layers as 3, take number of neurons as 1024, try the model. So I automate this entire process. Okay. So those are my 2 options. Automating is always beneficial because we don't have to do it manually in your code. There are so many different packages in Python that you can use to do this hyperparameter optimization. So this I'll just skip. And so before the start of the tuning process, this is what you have to know or you have to keep ready. One is what kind of model that you are going to use, whether it is if it is a task is image processing, you have to choose a model accordingly. If it is a simple machine learning problem, you just choose a model accordingly. So if it is a clustering problem, you choose k-means. If it is a complex pattern analysis problem, maybe you choose a CNN network. So you have to define first, fix up a model that you are going to tune. Next is you be ready with your data set. Third is evaluation metrics. Based on which metric you are evaluating, which is the best model. So mostly it will be the loss function. Okay, the loss function should output minimum loss, meaning the accuracy is more. Then you have to set up the tuning parameters. This is what we are going to see in detail now. So you have something called as a hyperparameter space. Hyperparameter space is nothing but what I just told you. You have x-axis one parameter, you have y-axis another parameter. So all the range of values that the x-axis parameter takes and the y-axis parameter takes forms a set of values, right? So that space is that 2D space of values is called as a hyperparameter space. If the number of hyperparameters you choose to tune increases, the dimension increases. Maybe you choose to tune 3 hyperparameters, then it becomes a 3D space. Correct? So that is nothing but hyperparameter space. Next, you have to choose which algorithm you are using for tuning. There are different algorithms. I'll tell you a gist of each and every algorithm in the following slides. Okay. Then you have to have a tuning budget. This is entirely different from a training budget. You have budget here refers to either time or the number of iterations. While training, you set something called as epochs or iterations, right? What does it mean? Number of times to go into the loop or number of times you can choose to update the weights in a neural network. That is called as epochs or number of iterations, right? Like training, you can also set a budget for tuning because model tuning also takes some time. Okay, if you want output in a real-time application, you cannot spend time for tuning. But if you have a application which is running offline, you have a lot of time to get the results, then you can fine-tune your model. So the budget here means that maybe I'm fine-tuning for 1 hour. Maybe I'm fine-tuning budget is 2 hours. Or I set it as number of iteration. Maybe I'll try 100 iterations and see 100 different model accuracies and finalize my best model. Maybe I have more time to spend. So I'll set the number of iterations to 200. I have 200 different models output and select one out of the 200 as my best model. So this training budget can be either number of iterations or number of, tuning time. Okay. Which one, sir? That depends upon your application. So entirely depends upon your application. Suppose you are building a neural network for a nuclear power plant where you want accuracy, but maybe you have a lot of time offline, not during the analysis process or inference time, but training time. In that case, you have to, because you need a lot of accuracy, you have to spend more time on fine tuning. In that case, you can choose a more number of iterations for training budgets. If you are not worried about that much accuracy, all you wanted to do is model size, then you can choose it accordingly. It is entirely based on whatever application you are choosing to do. Yes, it will take a lot of computational resources. If you are choosing to fine tune a model, it is going to take you at least some computational resources. Only if you're fine with that, you have to go for fine tuning. Otherwise, you can skip this part entirely. If you're happy with the model's performance, you can skip fine tuning. So there are different types of hyperparameters in any model. One is discrete, continuous, or categorical. Discrete means that it can take finite number of values like 1, 2, 3, 4. Like, for example, you have used decision trees, machine learning algorithm, decision trees. Have you used decision trees? Yeah. Decision trees, what is the hyperparameter? You have to set the maximum depth of a tree. That can be either, that means the level in the tree, right? That can be either 1, 2, 3, or any discrete number values. It can be it cannot be 1.1, 1.2, like that continuous values, right? It has to be discrete. So there are discrete hyperparameters. There are also continuous hyperparameters. Continuous hyperparameter means that it is in a range 0 to 1, 0.1 it can be 0.01 or 0.02 or 0.001 or 0.002 likewise. Okay, so it is a set of continuous values. For example, learning rate is the best example for a continuous hyperparameter. Then you have categorical hyperparameters. Categorical hyperparameters are nothing but splitting into categories. Like it has like labels. For example, have you used support vector machines? No. So you have heard about activation functions in neural networks. So you have different activation functions, right? ReLU, sigmoid, and tanh. So each layer, each of the nodes, you will have a activation function. So usually, depending upon the problem, you choose the activation functions. For sigmoid, what is the value? What is the range of values for sigmoid? 0 to 1. Tanh it is -1 to 1. ReLU it is maximum of 0, whatever the input value is. So ReLU will always give a positive output. Sigmoid function, if you choose to use a sigmoid function, your values will be between 0 and 1. If you choose to use tanh, your always output values will be -1 to 1. Okay, so based on the problem you have choose the activation function. But if you do not know which activation function will work for your model, you can also set that as hyperparameter and try different versions and pick finally one which performs well. Sorry. See, in this, this is just a simple example of the entire hyperparameter tuning process. So I have to choose between these hyperparameter values. So I'm choosing 3: learning rate, momentum, and activation type. Learning rate, I have 4 values, discrete values, 0.1, 0.01, 0.001, and 0.001. Momentum, I take 10 values in the range 0 to 9. Activation type, I have 3 choices: ReLU, tanh, and sigmoid. See that I have written a for loop, which is a nested for loop. So it is going to pick learning rate as 0.1, momentum 1, ReLU, run the model. Find out what is the accuracy. Next loop, it will take again 0.1, number 2, but tanh. Again, 0.1, number 3, sigmoid, run the model. Likewise, it will move, the end outer for loop is over. So it will be 0.1, number 2, and ReLU. Likewise, it will just move on. Correct? So how many models actually am I training? I have 4 values here, 10 values here, 3 values here, all nested for loops. So how many different models am I trying? it is 120. 4 into 10 into 3. So 120 models I'm training from scratch, evaluating the model's accuracy, and finally picking one best model which I'm happy with. So the tuning process alone is taking 120 different models to build. If you have budget for tuning, you can do this. Otherwise, you cannot do this. Okay. So from here on, we are assuming that we have enough budget to tune. So based on that, we have different techniques how to automate this hyperparameter tuning process, what algorithm to use. There are several different algorithms. I'll just tell you a couple of algorithms in detail. Grid search, random search. There are heuristic algorithms. Bayesian optimization methods, we have Gaussian process and something called as TPE. This is the one which is famously used. And bandit-based strategies are also popular ones where we have hyperband, Bayesian optimization hyperband. And meta-heuristic optimization, this is genetic algorithms and particle swarm optimizations. We are not going to see the last one, but if possible, I'll try to explain all these, or I'll explain a couple of algorithms in a simple way, okay? So we'll start with grid search, okay? Say that you have chosen 2 hyperparameters to tune. Plot that as a 2D space. Plot hyperparameter 1 here, hyperparameter 2 here. Okay. Say that hyperparameter takes values 1, 2, 3, 4, only 1, 2, 3, and 4. Say that hyperparameter 2 also can take values 1, 2, 3, and 4. Okay. So what I do in grid search is simple. I start from one end of the grid. I take this value. I set the hyperparameter 1 to 4, hyperparameter 2 to 1. Run the model, see the output. Move on to the next element in the grid. Likewise, I just keep one element at a time, take one set of hyperparameter values at a time, run the model, see the output. So how many different models am I training? 16 models I am training, correct? So what is the advantage of this algorithm? Can you tell me what is the advantage? This hyperparameter can take only one of the 4 possible values. Hyperparameter 2 can take only one of the 4 possible values. I'm trying out all possible combination. So I end up with the best model. Got it? But it takes time. If the number of hyperparameters is more, it becomes a multidimensional space. If the number of values or the domain of each hyperparameter is more, the number of models that you have to train increases. Here it is only 4 by 4. If it is 5 by 5, 25 models you are training. If it is 6 by 6, 36 models you are training. So if the number of values is more, the more you have to train to find out which is the best model. Okay, so that is a disadvantage of grid search. It is going to take a lot of time. But you will end up with the best solution. That is guaranteed. Okay. So that is what is explained in the slide. I'll give you this. I'll share the slide with ma'am. You can just go through it. Whatever I said is there, the slide. Next algorithm is random search. So as the name implies, what we do is, again, we form a hyperparameter space of values. Assume that there are only 2 hyperparameters. So there is a typo here in the slide. This has to be hyperparameter and this also has to be hyperparameter. Okay. So this is, say that this is a learning rate hyperparameter, taking values minus 0.2 to 1.2. Likewise, this is another hyperparameter which also takes values from minus 0.2 to 1.2. Okay. This can be any value in between. It need not be 0.2 because it is 0.2 and 0.4 here. It does not mean that you have only 0.3 in the middle. It can be 0.25. It can be 0.27 or it can be 0.276. It is a range of values. It is continuous values. Okay. So what I do is I make a space of this hyperparameter, pick out any particular value randomly, try the model, note down the accuracy. Next iteration, pick some other value, run the model and get the accuracy. Likewise, I can set a maximum number of iterations that I can go for and I have all the model's outputs, find out which is the best model. But the problem here is Problem here is I will not end up with a best solution. You have to settle for the near best. Out of the, maybe you are running the loop for 100 times. Out of the 100 configurations you have tried, you have to choose the best model. But that need not be the global best solution. It has to be a local best solution. That is what we call it as local optima. Okay, from what the space that you are trying, whatever is the best that you are choosing. Okay, but the advantage here is it is simple to implement. You are not trying out all possible combinations. You are just randomly choosing. So it is very simple to implement this algorithm. Okay. So is there any way that is better than random or grid search? What did we miss in random and grid search? What point we missed? Or if I have to rephrase the question, what is the one thing that the random and the grid search did not take into account when you're considering the next iteration? In grid search, we went one element in the grid at a time, right? When we are doing the second element, did we worry about what the first element's output was? No. When we were doing a third one, did we worry about the first and second? No. Every iteration is independent of each other. You are noting down only the results. Likewise, in random search, you are picking out the different configurations randomly. Configuration, by the word configuration, I mean that one set of values for each of the hyperparameters, okay? So if we pick out the configurations randomly, we just note down the results. If there is a way to remember the past and based on the past configuration that you have evaluated, if it is possible to choose the next configuration to evaluate, will it not be better? Yes. So that is why we have Bayesian methods. Bayesian methods are mathematical methods. It is based on the mathematical principles of Bayes' rule. Okay? I'll tell you what Bayes' rule is. So this is what is the Bayes' rule in general. So here H represents any hypothesis that you have formed. E represents the evidence that you have. Okay. So there is a famous coin example in mathematics statistics, right? You have a coin, you flip it. Maybe it is a biased coin or not, you do not know. Based on several flips, you identify whether the coin is biased or not. So the hypothesis that you frame first is maybe the coin is unbiased. Okay. What is the evidence you have? You do not have anything for now. You have not yet flipped even once. Okay. So what are you trying to find? Whether your hypothesis is true or not, given the evidence. That is what you're trying to find. What do you have? The probability of hypothesis being true without any evidence. You have not yet flipped the coin, but you are framing that what is the probability of the coin being unbiased. There is a 50-50 chance, right? So this probability is 50% initially during the first iteration. The next parameter that is there in the numerator is the probability of seeing this evidence if the hypothesis is true. Suppose you're assuming that the coin is unbiased. And what is the probability of seeing this evidence? You have flipped 5 times. You all end up with heads. Okay. What is the chance of getting 5 heads if the coin is unbiased? That is what is this probability represents. The denominator represents the probability of observing the evidence without the hypothesis. What is the probability of getting 5 heads without knowing whether the coin is biased or not? Okay. So this is the Bayes rule in general. So applying it to the hyperparameter tuning part, what do you get? What is the probability of this hyperparameter be giving the best model output given the evidence? Given the evidence means that whatever you have observed in the past. That is equal to the probability of hypothesis being true, probability of this term, we call it as likelihood. So probability of evidence given the hypothesis is true divided by probability of evidence. Okay. So here, if you look at the Bayes rule, you are looking at the past information. So you have already tried 50 different hyperparameter configurations and you have evaluated those models and you have 50 different accuracy values. Okay. Now, to do the 51st iteration, which configuration should I choose? You would have had 50 different configurations already evaluated, right? Maybe 25 of them have given accuracies more than 90%. 25 of them have not given enough accuracy. Maybe they are like 50% accuracy. You do not want to choose a configuration which is closer to that 50% accuracy model, right? You want a configuration to be selected which gives you an accuracy more than 90%. So you have to choose a point in that hyperparameter space which will contribute to 90% accuracy. So that is what this Bayesian optimization does. Okay, it will help you choose in a way such that you end up with searching the best regions in the hyperparameters space rather than looking at the regions where you have configuration which will not give you a good accuracy. Okay. For example, see if this is the hyperparameter space, obviously I cannot try all possible combinations because it involves continuous values. What Bayesian optimization does is it first randomly selects one, finds out the model accuracy, chooses the second one based on the first one's output, updates the model, finds the model accuracy and updates its probability distribution. Likewise, it will do say like 50 iterations. By the end of 50 iteration, it would have learned that maybe this region of the hyperparameter space is the one which is giving more accuracy. Maybe the next point that I should choose from will be inside this region. That is what Bayesian optimization actually does. Okay. So how it does is, it has something called as a surrogate model and acquisition function. Okay, I'll just explain it in simpler words. Surrogate, you have a loss function, right? In neural networks, you have the loss function. That is the true objective function which you want to minimize. You want to minimize the loss. Minimizing loss means that you are increasing the accuracy of the model. So loss function will be a very big mathematical function involving lot of operations. Okay, so every time you choose hyperparameter configuration, if you run it through the model, you end up doing a lot of calculation which takes up a lot of time. Instead, what you do is you build a surrogate model of that is also a probability model which will have only two columns. One is the hyperparameter configurations that you have already evaluated. The next is the model accuracy that you have found out based on the configurations. So this is a probability distribution in itself, right? So only by looking at it and not evaluating it through the loss function, you identify the next point to evaluate. That is what is the surrogate model and acquisition function do. Okay. It means that you are approximating the true objective function. You are not executing the function, but you are approximating the function based on the past values that you have already observed. I'll show you. Yes, sir. Numbers will become. Yes, it will. It will. If you do not choose a right initialization point, you might end up in a region where it will not give a. So some kind of randomization has to be included in whichever algorithm that Bayesian optimization has a base for. So some random values you have to give. So that's why you have the next strategy called as banded based strategy. I'll tell you in the following slide. See this picture here, first picture. So this is the function that you are trying to find. This is the true objective function's shape that you are trying to find out. This is where your maximum is, right? This is a curve. Where is the maximum? This point is the maximum in the curve. So this is what is the optimal solution as per theory. Okay, this is what you're trying to find using Bayesian optimization. So what you do is you start with some point, some random point. Okay. So because this Bayesian optimization is based on Gaussian process means that there is a constant mean and a constant variance. So this is the constant mean. This line shows the constant mean. This green part shows the constant variance, okay, in the data. You choose some point and update your model. Go to the next portion. See, this is the point. So you have updated the mean and the variance to mark it here on the true objective function. The next point to choose is here. Initial iterations, it will choose randomly. Okay. So it will choose here. Then it will update the model. You can see it here. So it has updated the model. The mean and variance have converged at this point. Then the next point to choose is this. So your graph becomes like this. Likewise, it will move on choosing points and given enough number of iterations, you will try to find this actual function. See, you have started with this. you have started with this approximation and you have ended up with resembling close to the true objective function. So which point to evaluate next is the one the Bayesian optimization probability will tell you. So the drawback is, no, actually in Bayesian optimization, a random variable part comes only initially. After that, you will not include any randomization. So that is what is a drawback of pure Bayesian optimization. That is why they have developed banded-based strategies where you can include randomization. That will show next. So the drawback, one of the drawbacks in Bayesian optimization is, as Sir said, you can get stuck in a local optima rather than going for the global optimum. Yeah. And it also does not work well for categorical hyperparameters. It works well for continuous parameters, discrete values. But when you have categorical hyperparameters where you have to choose from like ReLU or sigmoid or this or that or this or that, it will not work well. Okay. Because it is all based on probabilities. Okay. So one more Bayesian optimized algorithm is based on tree parson estimators. If you look at the algorithm, it will be confusing. I'll just tell you in simpler words. What you do here is, initially, in the initial, say, 50 iteration, you pick some random points and evaluate and find out the model accuracy. In that 50 points, maybe 30 points have given you a good model performance, 20% have given you not so good performance. So you club all these 30 points as a set of good points. You club all these 20 points as a set of bad points. The next point to evaluate in the entire space comes as a ratio between the set of good and the set of bad points. I'll show you the picture and I'll explain. So assume that initially you have done 50 iterations and you have formed a set of good points and a set of bad points. You draw it as a probability distribution. So this orange part shows you the probability distribution of a set of good points. This blue part shows you the probability distribution of the set of bad points. So the next point to evaluate, say that you are choosing 6 different points and 6 different points, and out of the 6, you have to find out the next best to evaluate. Okay. How do you find that? So this X, this is say L of X. L of X is the probability value of the set of good points. G of X is the probability value of the set of bad points. So if you take this point to evaluate next, what is the improvement that you get? Only a little bit, right? If you choose this point, the corresponding value in the blue graph is this. How much improvement you get? Some more, right? What about this point? Some more. This point, some more. This point, and likewise, you find out how much improvement you can do if you choose this point. If you do that, you will see that only this point has the, this point corresponds to this. This point has the most improvement. If you divide it and see that this will get the most improvement. So this is out of this 6 points, the next best point to evaluate is this. Not this. Even though if it is at the top of the graph, you should not say that is the best improvement. You have to see the difference. You have to see the ratio of the X values. So in that case, this will become the next best point to evaluate. Likewise, you have to continue. You will end up with approximating the true objective function. So this is how tree parson estimators work. Why it is called as tree parson estimators is because it will help you capture the hierarchy relationship between the variables. You can form a tree structure. For example, say that you have 2 hyperparameters that you have chosen to tune using this method. Say that one is the number of layers and the other is the number of neurons in a layer. Only if the number of layers is 2, you have to worry about how many number of neurons you can keep in the second layer. If you are choosing, if the best model has only 1 layer, you don't have to worry about how many neurons to keep in the second layer because there is no second layer. So this kind of tree hierarchical relationship, this algorithm will find better rather than the Gaussian process, because Gaussian process is truly based on probability distribution. This will take into consideration the expected improvement and also the hierarchical relationships. Which one, sir? Yes, that is our goal. You just give a initialization values. That is, you have to define the hyperparameter space. That is, the number of neurons can be 256 or 512 or 1024 or how many ever you want. Based on that, the probability distribution, it will pick one of these three values. That's all. It is not going to predict that this is going to be the best, but it will choose from whatever values you give. So this I'll skip because it does not need it. So the drawback of this algorithm is, so you have a set of good points, you have a set of bad points. The next point to evaluate is obviously going to come from a set of good points, one of the good points. But still, because your improvement is calculated based on the ratio of the good point and the bad point, you also have to keep updating the probability distribution of the bad points also. Okay, that is just a waste of time. Even though you are going to use only the good point values, you still need it for calculation purposes. Okay, so that is one of the drawbacks of TPE, that is tree parson estimators. One more thing is it will be difficult to parallelize. Any Bayesian optimization method is difficult to parallelize because it depends on the past value. Okay. So that's why the next set of category of hyperparameter tuning algorithms came into the picture. That is multi-fidelity optimization, or otherwise called as bandit-based strategies. Instead of just simply looking at the past, you are trying to find out, you are trying to balance between exploration of the entire hyperparameter space, that is where to find my next point, and exploitation of the hyperparameter space, that is the best regions that I've already seen. See, I have a hyperparameter space. Say that this portion of the space gives me best model accuracy. So if I pick a point here, meaning that I'm exploiting this region. I've already gained some knowledge about this region. I'm trying to pick one from the same region. But the problem with Bayesian optimization was maybe it is a local optima. Maybe my global optimum is somewhere in the other part of the hyperparameter space. So I have to include some kind of randomization. Right? So that balance between whether I'm going to explore the space somewhere else newly, or whether I'm trying to find the next best point in the same space that I've seen so far, that is exploitation. Exploration versus exploitation. That balance, you find it using these kind of algorithms. Okay, I'll just explain one algorithm in this. So there is a famous algorithm called as hyperband, which is a multi-fidelity based optimization. So what this algorithm does is, the algorithm has something called as buckets. Buckets is similar to iterations, which there is kind of number of iterations, like number of buckets. Okay, so there are n different buckets. Here, the buckets are, number of buckets is 4, 0, 1, 2, and 3. In this example, S is the one which denotes the buckets, or in otherwise called as brackets. Sometimes it is also called as brackets. Okay. So inside each bucket or a bracket, there are several different iterations. Okay. I denotes the number of iterations. So here in this example, we have taken 4 iterations in every bucket. Okay. So in this is the first bucket that I will start with. Here, Ni denotes the number of hyperparameter configurations that I will try in this bucket. Maximum number of hyperparameter configurations that I'll try in this bucket. Meaning, in the first bucket, first iteration, I start with 27 different hyperparameter configurations, which is run only once. The model is run only once for each hyperparameter configuration. That is what this denotes. This denotes the resource. That is how many number of times the model has been run with this hyperparameter setup. Okay. So I'm choosing 27 different hyperparameter configurations randomly, running every hyperparameter configuration only once. I find out the result. I calculate the loss. Okay. Next, out of this 27, I pick the top 9 performing configurations. Okay, I'll choose only those top 9. I'll drop out the rest. I do not want the rest. I'll pick only the best performing configurations, and that too only number 9. Okay, I'll tell you why this 9 came. Okay, then I choose to run the same 9 different configurations thrice. I'm reducing the number of configurations, but I'm increasing the budget by a little bit. Now I calculate the loss. Remember, this 9 always comes from the 27. Okay. Now, in the next round, what I do is, among the 9 configurations that I've tried thrice, I'm picking only 3 best performing configurations. Okay. So 3, I'm choosing it to run for 9 times. Okay. So it is a multiple of 3. You can just see that is determined by another parameter called as eta, which is also a hyperparameter which is set. Okay. Assume that this is 3. And out of this 3, I'm choosing the best hyperparameter configuration, running it for 27 times and noting down the model accuracy. So I'm leaving all this. I'm just keeping this value alone in the first bracket. Second bracket, what I do is I randomly choose 12 new hyperparameter configurations, run it with 3 times, run it for 3 times. Note the loss. Out of the loss, which is the best 4 performing configurations, I move it to the next round. Sorry. Run it for 9 times. I note down the loss. Among the 4, I pick 1. Run it for 25 times. I note down the loss. So I have 1 loss value here, 1 best loss value here. Likewise, I go for another bracket and another bracket. See, in each bracket, the number of configurations that I select randomly reduces, but the number of resources that I am giving to each configuration increases. Okay. So this is kind of a exploration versus exploitation. Within a bracket, I am doing exploitation. Correct? Out of the 27, I am picking 9 best configuration. Out of this 9, I am picking 3 best. Out of the 3, I am picking 1 best. Likewise, out of 12, I am picking 4 from 1. So within a bracket, I am concentrating on exploiting the best regions. Across the brackets, I am concentrating on exploring new regions because I'm taking 12 new configurations here, 6 new configurations here, 4 new configurations here. So this algorithm kind of balances between exploration and exploitation to look for the global optimum. So this entire algorithm is run for certain number of times. Whichever is the loss value, which is really less, that is the model that I'll make it as a final model. You cannot guarantee that it is the best model. You have to settle for whatever models that you have run for the given budget. That's all. Okay. So in conclusion, with hyperparameter tuning, what can you do? Which algorithm to choose whenever I'm doing tuning? If all the hyperparameters are real value, meaning that they are continuous, and you can afford only a few dozen evaluations for fine tuning, then Gaussian process-based Bayesian optimization is recommended because it works really well for continuous values. Whereas if you have a large number of continuous parameters and they're also conditional, meaning dependent on one another, in that case, a random forest-based Bayesian optimization or a tree parson estimators will work well because that will be able to capture that relationship very well. Lastly, for purely real value spaces and cheap objective functions where you can afford more iterations for fine tuning, then you can go for fidelity based explorations because that is the one which is trying to capture the exploitation versus exploration. So you need to have more number of iterations to actually find out which is the best. So when you have more budget for tuning, then you can go for fidelity. Otherwise, you go for grid search, random search, or Bayesian based methods. There are a lot of Python libraries which you can use for hyperparameter tuning. All you have to do is you have to import this library, call the method for tuning. Say grid search, it will call grid search. Say random search, it will call random search. All you have to do is define what are all the hyperparameters that you choose to tune, what is the possible values that each hyperparameter takes. If you give that input to the algorithm, it will give you which model is the best. Okay. I personally recommend, these are like open source versions which you can freely use. These are like paid versions. If you can afford, you can just use it. But out of the open source version, I've personally tried HyperOpt, Optuna, and Microsoft's NNI. Optuna and NNI works the best. This has really good visualization part. You can see visually which hyperparameter is contributing to how much accuracy in the model's performance. What is the combination of hyperparameters which gives you this performance? What does not give the good performance? You will be able to visualize as charts and graphs. Okay. So that's all about hyperparameter tuning. To sum up today's session, I'll tell you in a few lines what we have covered. So we started up with the paradigm shift that happened in AI. What are all the new technologies that are coming up and what you can take as possible research problems, right? We saw about, first, we saw about GANs, generative adversarial networks, where there are two networks which are opposing each other and working. One is trying to fool the other is trying to get itself better with the output of the first one, right? So that is GANs. There are different types of applications. Then explainable AI, where your output's explainability is important. So if you want interpretability, you can use any of the explainable AI models. Then transfer learning. Transfer learning is where you take knowledge from one network and apply it to another task, similar task. That is transfer learning. Then federated learning, where we had, instead of putting everything into a central server, we decentralize the approach. You process all the data that are there in the local devices and only send the weights to the central server. Model updation happens in the server. Okay, that is federated learning. Then we saw about edge AI. Edge AI is no central server, it just maintains all the hardware devices. That's all the work of the central server is. All the processing is done in the edge devices itself, and in real time, you'll be able to see the results. For example, we saw a smartwatch, right? Then we ended up with the model compression techniques, pruning and quantization. Pruning is removing some of the structures in the model like weights and neurons, whereas quantization is how you represent the weights. Instead of floating point, you just put it as integer values. Then finally, we saw model tuning. We saw what is hyperparameter, how is it different from a parameter, how to set budgets for hyperparameter tuning process, and what are all the different algorithms: grid search, random search, Bayesian-based methods, and bandit-based strategies. Okay. If you have any doubts, please feel free to ask. I'm personally working in model optimization, model compression techniques. I've also published some papers which are based on hyperband and Bayesian optimization hyperband. I've published my own algorithm, and which is called as adaptive Bayesian-based hyperband method. And then currently I'm working on model compression techniques for resource-constrained devices. So if you have any doubts on that also, you can ask. Yes, please.
While doing hyperparameters, how should we choose the optimization technique on choosing about the learning rate and the hidden layers? And also, should we give concern about the overfitting on that?
You should be concerned about overfitting, but the hyperparameter tuning algorithm itself will give you a best model, right? It means that it is finding out a model which actually performs well for the given kind of input, because you are evaluating the model using the validation data set that you already have, which is also part of the data set. But you have to be concerned about overfitting, but you can avoid overfitting using the regularization norms like L1 norm, L2 norm you have, right? So you can use that. You also have hyperparameters in the regularization norms like alpha you have, right? So you can choose that also to avoid overfitting. That is the answer to the overfitting question. The other question is what kind of hyperparameters to choose to tune, right? That depends entirely upon the application and the budget that you have. If you have a complex neural network, which you really want to reduce the size for, then you can choose a number of layers and number of neurons as a hyperparameter. If you are not worried about the size, you can just leave that part. If you only worry about the complexity of the model, then you can choose learning rate as a hyperparameter. So it entirely depends upon what kind of application you choose. Okay. Did I answer your question? Yeah, thank you. Anyone else? Derive on learning rate in the sense? Yeah. No, there are no standards. You can go with the domain expertise. For example, say that you are using an image processing technology, or you want to build a neural network for image processing. You would have done some literature survey, right? In the most of the papers, they would have mentioned what is the learning rate. That experimental setup section, they would have mentioned what is the learning rate. You can choose to go for that. But if you are fine-tuning the model, if you want your model's output to be really, really well, then you have to go for hyperparameter tuning only. You have to select at least 4 or 5 different values that you can base on the literature and find out which works the best for you. That's all you can do. There is no standard procedure to pick that, say that this learning rate will work for this kind of a task, or this learning rate will work for this kind of a task. It all depends upon the budget that you have. Any other questions? Thank you so much.
Thank you, ma'am. As a token of our gratitude, I kindly request Dr. Mary Jacob to offer a memento and certificate to Dr. Lakshmi Priya. Thank you, ma'am, for sharing such valuable insights with us today. Your expertise and perspectives have truly enriched our understanding and sparked meaningful discussions. We deeply appreciate the time and effort you have taken to guide us through this enlightening session. Thank you so much. Now we are moving to case study presentation. Now I request Dr. Gobika to take over the session.
So, dear participants, as we discussed last day, we'll be having the presentation of case study, and we request Dr. Lakshmi Priya to be seated and to judge the various presentations which are going to happen here. And ma'am may not be aware about what is this case study presentation, so we'll give a brief overview. So, as part of ATAL norms or ATAL criteria for completing the certification, all the participants were divided into groups. So, every group is having minimum 5 or maximum 6 participants, and for each group, we had given a theme or a word. So, what it was is an AI tool which is used in medical diagnosis. So, one group has got IBM Watson tool for diagnosing cancer. Another group has got a tool for diagnosing lung nodules or breathing issues. So, like that, each and every group, they picked a topic and they are asked to give a brief presentation. Presentation, as we told, again, I'm reminding the maximum time of presentation can be 8 minutes. If any question answer session, if it is happening, maximum it will go till 10. And as we know, every group is having 5 or 6 participants. We welcome everybody to be on the stage, but it is not mandatory. Minimum 2 participants should be there on the stage for doing the presentation. So it is just a knowledge sharing session. We are not going to assess you, we are not going to measure you, but it is a knowledge sharing session where you will be transferring what knowledge you have shared to others in the team. So this will happen now. So till 1 o'clock, we will be having this case study presentation. And then as you are aware, tomorrow we have the IV. So afternoon, you will be going to click as part of your IV. So at 12:30, we will be going from here. So before that, we'll wind up our lunch. And then after the IV, those who wish to come back to campus, you can come back here. Those who are staying nearby. Otherwise, from there itself, you can disperse and go to your respective venues. So that is the plan for tomorrow. Nobody should take leave or absence tomorrow. And from 12:30, bus will be plying from here to the venue. So details about the venue and the other things that we are supposed to do, that Kalai Selvi madam will be sharing with you in the afternoon session. Okay, so that is the plan. And now in the participants group, I had shared a mail ID. My mail ID I have shared, requesting all to share your PPT to that mail ID. We'll open that and we'll be sharing the slides from here. And thank you, ma'am, for accepting our invitation as resource person and also for judging for this. Any other clarifications or queries are there from the participant side? So we request group 1 members to come forward. So you can start with introducing your teammates and introducing the topic, and then you can have a brief presentation. So make it interactive. Others are requested to ask queries.
Check. Check. A very good afternoon to everyone. I just want to thank Kristu Jayanti for giving me this opportunity and also for my team to do a presentation on skin vision AI powered skin cancer detection. So this is Team AI Avengers. So starting off with the presentation. Okay. Back. So imagine your smartphones can literally help you to detect cancer in your skin. You know, uh, considering cancer as a topic, cancer is something which is something dangerous to a human being, which grows rapidly in one's body and it's contagious. So in order to stop cancer, you literally have to operate it, and there's so many procedures, for a cancer patient to undergo in order to prevent cancer. And the survival rate is quite minimal, considered cancer, as a disease. So imagine you have given this application which is powered by artificial intelligence, where you just take a snap of your skin and it just predicts, like, do you have a cancer, or are you in a stage of developing a cancer. So So talking about skin cancer, our human skins are made up of three layers. The first layer is the topmost layer, which is epidermis, and the second layer is dermis, which is the middle layer, and the third layer is the bottom layer, which is hypodermis. So skin cancer can be divided into two categories. One is the melanoma and the non-melanoma. So melanoma is something serious. It's a growth on your skin which starts with a pigment, and it continuously grows, and you have to literally go through chemotherapies and different procedures to to prevent it. And non-melanoma is something, it's a base level of cancer which is experienced almost with everyone, and it can be prevented. So, talking about melanoma cancer, skin cancer, this is something serious, and it's better for us to take precautions as early as possible to prevent this. and out of 1 out of 5 people consider, 1 out of 5 people get cancer, as per the stats. So, so talking about skin cancer, how common it is. Skin cancer is, is more common worldwide, and and people in UKs and US are prone to this skin cancer because they have a very lighter tone of skin, and it's quite minimal in Asian countries because our skin tone is quite dusky and dark. So
Sorry to interrupt you. One query. Can you tell about the AI aspects of
yes,
this?
ma'am. Yes.
Okay.
So there are two types of problems considering skin cancer. One is unaware of the health skin, and second is limited access to healthcare. So we face these two types of problems where a person is literally unaware of what's happening in his skin, and the second one is he or she has a limited access to the healthcare. So this eventually increases the demand of healthcare and also decreases the supply of healthcare. There's a rapid increase in the demand and the decrease in the supplies, which eventually rises the healthcare cost. So, in order to understand this in depth, I would like to call upon my friend Chandan to understand, to give you a more understanding of how this application works and how it's been developed by a Skin Vision. Over to Chandru.
Thank you, Robert. So I am here to explain about how this Skin Vision app works. So basically, it is an application which can be downloaded on your mobile device. So what happens is, initially you take a photo of what you call it as lesion, skin lesion. So skin lesion is just the skin which is not normal. So there are some abnormal scars in your skin. So those photos you have to take it, and you will get it to upload in that. In the space provided in that in that application. So when you upload the skin lesion images, it undergoes some pre-processing. So it the what the application does, it removes a certain noise, and it normalizes and segments. So noise means that's the that not that thing which should not be considered for processing and thing. So it will be removed through that pre-processing. And in feature extraction, it just sorry it just removes the asymmetry. The symmetry, it takes what necessary, than leaving out what it is not needed for the processing. So at using computer vision techniques, so that is what happens. So you can see the lesions. So you can see the lesions in this images. These are the skin lesions which are considered to be as cancer. So now, apart from normal skin, these are the lesions. So in feature extraction, so you can see that the feature extraction photo, the only which is required things are all taken to the next step. So these outer skin will not be included for the next step. So this is how feature extraction and pre-processing works. So next slide. Next slide. Oh, thank you. So in pre-processing, what happens is CNN. They use convolutional neural networks for processing the image. So what happens is they have already pre-trained millions of dermatological issues, the skin photos which has issues in it. So what they do is they use ResNet and InceptionNet to extract hierarchical features. That is, which features are important for detecting the cancerous part of the skin. So they use ResNet and InceptionNet, and they train using the transfer learning and data augmentation technique, in which the image is rotated as needed, like for comparing the present image which you uploaded and the images, so data set of the images they have. So they use the transfer learning and data augmentation and convolutional neural networks to do this pre-processing. And so in this, at last the AI, what it does is it detects the whether the cancerous the skin which you uploaded, the part of the photo, is high, the risk level of the cancer, you getting the cancer. So there are three levels of the risk. One is low risk, second is medium risk, and third is high risk. So it detects using how the image and their data, and it compares it and tells us whether you have the risk of getting the cancer, or whether you can just so if it is a low risk, no immediate concern is required. You can like continue checkup on some points of your life. So then comes medium risk. So it needs monitoring over time. So you need to keep checking throughout like some from days, weeks, or later. So sometimes like that. And high risk. So it is like potential. You have the more potential to get cancer. So it will suggest you to consult a meditation or expert in skin cancer thing. So next part will be explained by. So the application is available in the Play Store and App Store. So you can download it, and it will ask you some. You take a picture of this abnormal skin you have, not the normal skin. Not normal skin will not be considered. Abnormal skin will be considered, and you need to give which body part, in which body part you have that abnormal skin. So that will be considered. And the second point is it will ask you some questions like if you are wearing a sunscreen every day while going out, if you are mostly exposed to sun, or you are staying in the shady area, and some your age and some basic yeah, prerequisite data about you, and then it will consider all those things using the backend process of using CNN. That's it. Yeah.
Thank you, Dhanush. My part is benefits and challenges. First, we can see benefits. Early detection by using um, mobile smartwatch. We can detect early, and we can accessible with smartphone only. And cost effective means in smartwatch only we can see all these details about skin cancer. And continuous learning means we can get updates about your skincare, what is that stage, and how it is. And next we part challenges. Image quality affects accuracy. If image is uh, in higher quality, then it affects accuracy of results. Possibility of false or positives or negatives. Next point is not a replacement for professional diagnosis. Next topic is future and conclusion of AI in skin cancer detection. Future of AI in skin cancer detection. Improved AI models for higher accuracy. It's integrated with wireless for real-time skin monitoring. Expansion to detect other dermatological conditions. Here, dermatological means skincare experts. Next point is partnership with skincare providers for wider adoption. At last, we can see conclusion. Skin vision is revolving, revolutionizing early skin cancer detection through AI. Provides a fast, accessible, and reliable tool for skin health monitoring. Future advancement will enhance AI's role in dermatology. Thank you.
So thank you, Group 1, for that informative presentation. You have done well. So
Yes. What made you choose this app? Did you try out any different apps that are already available in Play Store?
Is accurate or not. So most of them, when I approached the Play Store, there was some reviews saying no, it is not that accurate to what I have. So they have. So yesterday I just checked whether I can just be currently I don't have much skin lesions, but I checked for something. So it showed that I have 94% risk of getting cancer. So I have no idea like if it is whether it is based on the questions what we answer or based on the image that I have taken. So I had uploaded a normal skin image. I didn't know that we should upload a skin image on something kind of thing. So just upload a normal skin image, and then it asked some questions like if you vote on sunny places more, or you are wearing a sunscreen or something like that. So I just answered based on what my routine. So it just gave me that you have high risk of getting cancer. Please consult your meditation as soon as possible. So I even in the Play Store it has three.
You see other customers' reviews there.
Yes.
They are telling
So
it is good or bad or how
it was mixed reviews. Like the overall point out of 5 was 3.
Okay,
So it's not like
average.
it's completely working or it's not like it's not at all working. So it's kind of in the middle.
So just simply we can check and if needed we can go to doctor and have a direct
That's
consultation.
so for me, it's just
Okay, okay.
94% of risk getting of cancer.
So we should know that such a tool is there. So that is what the objective of this presentation. Thank you so much. Thank you. Group 2 can come. And the food is ready. We will buy the food. No, 6 are there. We will not be able to do it. You will look like extra 20 minutes. No problem. You should have given the new picture that the food in no, you be like this only. No problem, no problem. The assumptions are not there. Good, good.
Good afternoon, everyone. Uh, our team name is Board Brigades. My name is Priyadashni. So the topic which our team is going to present is Google AI powered diabetic retinopathy. Actually, I would like to brief little bit about Google AI community. Basically, like it is an the community that works for many domains like health and even uh, for the many domains. So we are emphasizing on healthcare. So this is like diabetic retinopathy. What exactly it is? So basically, if a patient is having diabetes, it is the highly chances of getting the retinal eyesight problems related. So the blood vessels will get fragile and weak. So initially, the symptoms will be normal, low vision and even blur seeing. So in initial tests, we can't identify uh, the impact of this disease. So further, when it goes to next stages, that is when we usually detect. So the challenge is like in normal OCT or any other techniques which is in present days, we have been used that can't examine in the initial stages. So using Google AI, that is the which newly they have designed and modeled. We use deep learnings, that techniques and all to analyze and examine that. So how this disease prevalence means like how this disease has been impact globally. Basically, this is like in other countries as well as in India, like in US and all, 30% of old age, like if we take the case of like 60 years plus or 40 plus ages, they are getting affected because of this. If we see in India nowadays, it has been increased. So what it leads to, as I told, low visions, and it may cause even for blindness. So challenges, as I told, like in old techniques, they used to inject and check. Even we use that dilate eye drops and expand the pupil and analysis. We need a particular technicians to analyze using the graph of OCT, that and all. So Google has used is like they have trained using deep learning, and which if we keep an image like while it gets scanned, so it analyzes and gives you the output. Like we can just go through the reports. Like further more slides how it works and that and all will be explained by Kevin. Thank you.
Good afternoon, everyone. I'm going to explain about how this model works. So first, we give AI the input image of the eye, and then the AI it processes the image and it identifies any abnormalities, and it provides with the diagnostics and what to do further. Deep learning enhances diagnostics by identifying this disease, and the accuracy it detects with high precision, reducing misdiagnosis, and it is very efficient. It has faster image analysis compared to manual screening, and early detection. It AI can identify it early, and humans can miss what AI can find. AI can it this can be accessed in remote areas where specialists are not available. It can be made possible to in underserved areas, and also we can reduce the burdens on the specialists to focus on to make them focus on critical conditions, and vision protection. By detecting DR early, it prevents blindness. As if we detect early, we can prevent it from causing blindness. Deployment. AI screening is being introduced in multiple countries now. It's still being introduced, and it has collaborated with Google, with healthcare organization to implement the technology. Together, we can prevent blindness and improve vision health for millions worldwide. Our AI technology represents a critical step towards more accessible, accurate, and equitable healthcare. Thank you.
Thank you so much. So in this also, is that an app?
No, ma'am, it's still being implemented.
Oh, okay, okay. Okay. So that picture which you have shown, through that they will be checking the.
What actually is the output of the tool? Okay, good job.
Group 3, Priyadarshini. Come, Priyadarshini. Group 3 can present, and after that we'll break for lunch.
Good afternoon, one and all. I am Jayashri Yu from Acharya Institute of Technology. I am very glad to stand here for our presentation. We, the team members of Cognitive Crew, are here to give you a presentation of IBM Watson for oncology. Yes, sir. Yeah. Uh, Watson was named from a Thomas J. Watson, who was the CEO and founder of IBM. It was found in the year of 2012, but Watson for oncology was announced at 2015 and was launched at 2016. It is a AI-powered decision support used to assist the oncologist with the AI treatments for cancer assistance for recommendations. It uses machine learning and NLP, natural language processing, to give the patients the appropriate recommendations using the already fed data. Uh, it is developed by IBM and MSKCC. MSKCC means Memorable Salon Catering Cancer Center. The application provides the treatment, means cancer recommendation, for the reason the application is being developed. Yeah. How it works? It uses AI for AI and machine learning to analyze the treatment. Once when Watson is fed with the patient's records, what problem they have, what are the symptoms, and all the reports, the physiotherapist asks the Watson for treatment recommendation. After taking few minutes, the Watson gives the response of what are the recommendations that a person can be taken based on the given fixed data sets. Once after the recommendations is given, the same application just gives the scores or ranks based on which treatment should be recommended. There are 3 ranks based on the appropriate patient's report. One is green, that is recommended for that patient. Another is yellow, that is for consideration. And third one is red, which is not recommended to the patients. Even the application has the proper record why that rank is given to that, so it can explain, it can give us why that rank is given for this treatment. This is through black box in machine learning. This is the process how it works. The patient data is being given into the Watson for oncologists. The database is taken from their guidelines, case reports, whatever is given. On that basis, through the clinical studies, like going with the trials and all, the final diagnosis is given to the physicians. Next, I request our teammate to continue it. Thank you.
Good afternoon, everyone. So we'll move on to key features of oncology by IBM Watson. So the first one is AI-powered decision support. Here, as we know, this is an AI decision-making equipment. Okay, here they are giving the oncologist to assist which treatment they can give to the patients. Okay, so they were assisting the AI, that is IBM Watson, to get the new ideas how they can treat the patients. The second one is personalized treatment recommendations. They have a tailored treatment recommendations to the oncologist, where by using their medical history and the cancer types. And third one is evidence-based insights by learning different types of journals, okay, which they already released through the different states where their patients are going through. By assessing all these journals, they found which treatment we can give to the patients. The fourth one is clinical trial matching. That is, we all know the patients will be not treated easily. They'll be going through different phases. Okay, so they'll be giving first medicines and they'll be treated. If it is failure, they'll be treating with some other treatment. So here they have taken recommendation from IBM Watson to check which treatment or which phase is giving good decision or which phase is giving good treatment for a patient to to cure the particular patients from the cancer. And next is data-driven learning. We all know the data will be updated daily basis. So with the new data, they will be developing new treatments and they'll be researching and they'll be developing new treatments which they can tell to the oncologist, which they will be trying and which they will be treated. So through this data-driven learning will be helping the oncologist and doctors to overcome the issues what they are facing right now. And the last one is global accessibility. So IBM Watson was introduced in 2016. Actually, it was launched in 2012, but it came to the introduction to the world in 2015, and it was accessible by 2016. But I can say IBM Watson is not live now. It was closed by 2022. It was a failure. But still, this was global accessible. That is every hospitals, that is EHR, that means electronic health records. Okay, this is very much linked to the EHR of all the hospitals. Okay, so we'll look into benefits of Watson. So the first one is faster diagnosis and treatments. As we know, AI is assisting which one? The treatment which we can give for the patient. So it is giving the fastest recommendation to each and every patient by checking their personal medical history. And the second thing is as a latest medical research. So we already mentioned that data driven. Okay, that means whenever we are updating our data, so it was giving to the particular, that is KCC, that is Memorial Sloan Kettering Cancer Center. They have given the particular access for 300 textbooks and 300 journals, that is comes in 15 million pages. Okay, after going through all the researches, they found which is good for the particular patient. But what happened is later it was diverse in patients, because each patient will be having different cancer types, and they will be having different stages. So they have given from the latest research. Next one is support of oncologists. So no one is more experienced. There will be new freshers. So by assisting the particular Watson, they are helping the less experienced doctors to give the good recommendation to the patients. Then can integrate with, as we already mentioned, EHR, that is electronic health records. So it is easily linked with the EHR in all hospitals. Okay, so as we know the benefits, we want to know about the challenges. The first one is accuracy issues. As it is a failure, there was a lot of accuracy issues which is given from the Watson, and it was not applicable in every patient. Then second one is dependency on limited data. That means the data which is given, I already mentioned, it was not diversely given for, it was diversely in patients. So it was not it is not actually applicable, and it is not actually working out in every patient. So it was a dependency in limited data. And next one, high cost. As it is an AI tool, it's not easy to implement in every hospital. So the smaller scale hospitals are facing a lot of problems and financial issues. They are not ready to apply into their hospital. So it is because of the high cost. And next is complex integration. Complex integration comes under same EHR. So whether the patients which they are ready to integrate or they are ready to apply it, because of the financial issues, the hospitals in smaller scales, they are not ready to implement. So there is a problem with the integration to all over the worldwide. And commercial failure. Commercial failure means in the beginning they had a agreement with the Korea, China, but what happened is the hype what they created was not actually meeting our expectations. So actually they went down. So that is why in 2022 the Watson has been closed. Now it does not exist. So because of the failure of these many challenges what we face to the Watson, and this adoption issues. Adoption, as I mentioned, Korea and China, the adoption was not possible because of their expectation was not proper. Thank you.
Thank you. Thank you for that detailed explanation. So sir can also continue. Requesting you to quickly.
Good afternoon, everybody. My name is K. Santosh. I'm from IIIT Kottayam. So we'll discuss about the impact and discontinuation. As my team members have said that this IBM Watson, it was discontinued in year 2022. And what was the impact basically? Raised awareness of AI in healthcare. So the impact is that, nowadays you can see that most of the, research which is going in healthcare, and it has actually ignite a spark, within the community, that they take up research and they come up with new, research and new advancement in making AI, accessible to healthcare. And then other impact was the adoption in global hospitals. See, after the implementation, after the failure of, we can say, Watson, so most of the hospitals, they recognized, because it was not a complete failure, it was a partial failure. So they recognized that somewhere it can actually bring out an impact. It can actually bring about a change in the way the patients are treated. So that was one of the impact. And third impact is the mixed clinical effectiveness. So when you combine technology and treatment, So it gives you a new spark. It gives you a new areas of advancement. It gives you a new way to approach the treatment. So that was one thing which most of the research scientists, the physicians, they recognized, and they came up with a new approach to the healthcare, the way they can treat the patients. And discontinuation, as we have said, Watson has been discontinued. It has not been discontinued. We can say that it has been sold to a company called Francico Partner. Francico Partner, they have come up with a new company. They have Maratin. It was sold to Maratin in July 2022 7th. So that this Maratin is a company which actually works in a lot of applications which actually bring about a change in healthcare, and they have a lot of customers which are actually existing in healthcare domain. So it's not been completely discontinued, but they've taken out the good part of the IBM Watson, and they are implementing with new solutions in this organization. So we cannot say that Watson has been completely discontinued. We can say that it has come over a changeover. Go to the next slide. Now, we will speak about what are the alternatives. After Watson, there are a lot of research, there are a lot of organizations who have actually started working on healthcare, bringing AI in healthcare. So there are some of the few organizations like Tempus AI, Flaritone Health AI, Page AI, Google DeepMind, and AlphaFold. So these are some of the organizations which are actually working in different domain of AI. Like if you speak about Tempus AI, it's actually helping to make medicines, because perfect medicine is something which is required. So what they are doing, they are bringing all the clinical data into their library, and they are helping the drug designer to access those data and to help them in designing a perfect medicine, which will be actually helpful to a cancer patient. Then when we speak about Flaritone Health AI, what it is doing basically, it is bringing the best of medicine and technology together basically. So technologists and the medicine research scientists, they are coming together. They have built up a library where they can access the data, they can share data, they can also refer to past clinical data, which is also required to come up with the latest with the best of medicine. So they have built that kind of library, which actually helps them to helps all the best of mind to come together and design a drug, a treatment for the cancer patients. And then Page AI, we can say that they have also they have also built up a decision making kind of AI platform, which also helps to plan out the kind of treatment. If some patients has come in and then looking at the lot of their reports, they actually help physicians to design the treatment. So these are different kinds of platforms, which has come up and which actually assist in helping the cancer patient, which helping the industry, helping the drug designer, and bringing an advancement in the treatment of cancer oncology. So now we speak about the future of AI in oncology. AI advancement in diagnosis, treatment, and drug discovery. Actually, we have discussed. There are a lot of efforts, a lot of research scientists, a lot of organizations are working in this domain. So this is we can say that future of AI is something. It will bring a greater impact in the way the cancer patients are being treated. And the second one is the integration with the real world patient data. That is what is happening. What I spoke about, some of the other organizations, and most of the organizations who are working on, they are bringing the real time data and pushing into the models, the machine learning models, and they are trying to bring out a real world applications, which can be given to the patients so that they recover faster. And there is early detection of cancer, because early detection of cancer is something very important. If it's detected at a later stage, then the recovery is very slow, and most of the patient loses their life. So that is how the current industry, technology, research scientists, physicians, all of them are working together so that they build up a platform, and the world will be able to fight against cancer. And we see that one day, like we don't have polio nowadays, so we come out of this cancer, and the society is a cancer free.
Thank you.
Thank you so much.
So it's clear that the team has done a detailed learning and research on this. Thank you so much for that knowledge sharing.
No. Good job, sir. Thank you.
So thank you, team. Now we will break for lunch. And a few of the participants who were absent yesterday, Vasudeva, Santosh Gokavi, Nawaz Sharif. So I think you have not signed in the sheet yesterday. In the sheet means Article 1 summary report. Please put the signature and then we'll break for lunch.
Good afternoon, everyone. It's our pleasure to welcome you to session 2 of day 4 of ATAL Basic Faculty Development Program on mastering the frontier of artificial intelligence, trends, challenges, and applications. We look forward to an insightful and engaging session ahead. It's an honor to introduce our esteemed keynote speaker, Dr. P. Mrinalini, Associate Professor, Department of Computer Science and Engineering at SSN College of Engineering, Chennai. Ma'am has 4 years of industrial experience and 18 years of teaching and research experience. She is a member of Machine Learning Research Group of SSN and is consistently taking part on shared tasks introduced under Clough Initiative Labs to promote the evaluation of technologies for annotation, indexing, classification, and retrieval of multimodal data. One of her papers was awarded the Best Paper Award at an international conference. Ma'am, we are privileged to have you amongst us today. I would like to invite Dr. Mary Jacob, Coordinator ATAL FDP, to welcome our keynote speaker, Dr. P. Mrinalini, with a sapling. Thank you, ma'am. Now I request Dr. P. Mrinalini to take over the session.
Yeah. Good afternoon to one and all present here. I'm here to discuss about the impact of AI in medical industry. I first thank the coordinators, Dr. Mary Jacob ma'am and Dr. Gopika, in order to way she has provided us this opportunity to take part in this ATAL FDP. I think I need to get a copyright from all of you because I have seen all your case studies. So whichever you have taken as a case studies, this is what we are going to discuss in our today's session because you have already proved that the impact of AI in the medical technology or medical industries. So that is what is my topic. So we'll have this content as the part 1 of our session. We'll have the introduction of what AI is. I think you have already done with a lot more of times because of this 4 days of FDP. So we'll have a slight change definition of what AI is. And then we'll move on to what is the global healthcare challenges? What are the challenges? What make us to rely on AI? So we'll discuss on these global healthcare challenges. And then, as we all know, that this AI cannot be done as an independent one. It is not as such we can switch it or wire it with some other component and say I have done with AI. It is mainly due to some technological innovation that makes us to work on this one. And this has been proved because of the digital era where we are looking for or where we are all in, where we are possible to collect a multimodal data. So the technology innovations we will be talking on what makes us to develop an AA. And then we'll also look on to this, what is the role of AA in healthcare? Healthcare is a single word, but it consists of many different categories. So we'll look on to all different roles of AA in healthcare. So I'll not be discussing more on this part. I'll be discussing where AA can be used and what is the AA which is promptly used in real time. And I will be touching upon how it will be using it, what is the name of it, where it will be using, and how it will be using. And I will be more concentrating more on one important role. It is all about the medical imaging. So I'll be taking all the text cases or case studies with respect to the medical imaging. I will be starting with an unsupervised learning, how I have done with an unsupervised learning. And really, I will be talking only with the skin liaison, segmentation and classification. So I'll be talking how it has happened with an unsupervised learning. Then I will be moving on to a supervised learning, where I can apply a deep learning technique. So I have done a research entirely throughout my research career with my skin liaisons and segmentation alone. So I'll be growing along with the AI. So what are the different techniques that can be adopted and how these results have been improved with the different techniques will be discussed in the next session of this FDP. So in this session, in order to prove the impact of AA, I'll be taking another case study. It is all about the segmentations. I hope that everyone knows what stenosis is. Yes, it is all about that causes the heart attack. So we'll be talking about how about this stenosis, where it will be present, how you detect the stenosis with the help of your deep learning technique. This is what is my talk. So moving on to the first one, as I told you, this AA, we all know, it helps us to develop any systems which impacts the human intelligence. What human can do, if it any system or a machine learning algorithm or a model can be able to do, I can say this is an AA. Yes, any automations can be called to be an AA also. So this is what is an AA is all about. So when you think it of this whatever you have discussed as a case studies, one person have told that I have detected cancer with the help of the photo cameras or images taken from the camera. And another person has told that they have detected something with the retinopathy, diabetic retinopathy. So we have different diseases, and the imaging modalities differs for each and every diseases over there. So all you have proved is it is possible for the machine to detect even the cancer. We are thinking cancer is the most dangerous disease. But as simple as that, you are saying that I am using my phone. I am able to capture an image from the phone and I'm giving it to the application where it predicts something about the cancer. So it is possible, and it has been proved that it is the machine can able to detect cancer as that. The next question is it the accuracy? We need to talk about the accuracy. The person who talked about the skin application, he told that he has been recognized as he has been predicted to have a cancer within 94% of chance of getting the cancer. So that is what is the next thing. So whether these type of AA or the impact of AA will replace the medical experts or not. So we cannot say that these can be replaced by the medical experts, or the revolution of AA cannot replace the medical experts. All we can say is, I can say it can be used as a first level of filter. Yes. So in order to make it automated, or otherwise I can say to make the process to be very speedy, or in order to avoid all my inter-observer or intra-observer differences between the experts, I can make use of the system. I can make the system to act as the first level of filter, and I come to a decision whether this person has to be treated immediately or not. This type of thing can be done. It cannot replace any persons over there, any person or any medical experts over there. So that's why, because this medical peoples are the medical persons, whenever I go with some system developed with my deep learning model or a machine learning model, they never used to look onto the system itself. They never accept the system itself. Even though my system says I got an accuracy of 98% or 99% in using my deep learning model, that person is not accepting that one. Because why? They are not able to trust the system. So in order to prove that one, we have developed the technology, which is what is called to be an explainable AA. I'm able to explain which features makes my system to say whether it contains cancer or not a cancer. Yes. So it provides a trust to the medical persons over there. So we will be talking about the development of AA and a case study which says how this improvement have been happened in the accuracy part of this one. This is how this flow of my talk will go on. So I can say it is, and again, when you talk about the COVID state, you just think it of when there is no machine or nothing, no AA has been developed for it. There is a report stating that AA has first given the report that there is some COVID-like disease to be spreading over before an official report came. And this particular part, because of this AA revolution only, or because of this AA used in the health technology, we ended up with some vaccines within a short period of time. That is to be a proven example that we have seen the last 3 years. Yes, we all got a vaccine at one shot. Yes, how it happened. It happened all due to this AA revolution only. So we'll discuss all these things in this talk. So whenever I look onto my AA, we need to know about the 4 important things in it. One is what is called to be machine learning. Whenever I talk about a machine learning, I can say it is all about a simple form of AA where it needs some intervention from the human, because whenever I say I am applying a machine learning technique, you just take an image. I want to classify the image whether it contains a cancer or not. It might be a skin lesion image, or it might be any image, whether I want to classify whether it contains breast cancer or whatever it might be. I need to say whether this in particular image contains cancer or not. This is what is my aim. When I look onto this one, I cannot say, look onto it as a I am not a medical expert to say whether it contains a cancer or not. So what I can do is I can extract the features from the images. Yes. So extracting the features, it might be some preliminary features like color, or it might be the shape, or it might be the texture, or whatever it might be. All the important features of the images has to be extracted. So whenever I say it is an image, it is all about a matrix of some sizes of 255 from 255, and it has some pixel values over there. With only the numerical values, I cannot say anything. So I will keep looking on to my image processing technique. I'll look on to my image processing technique, find out the suitable features. I need to decide on which features helps me to distinguish whether the particular image contains cancer or not. That is one thing that I do. So what I will be doing, I have to look out on my important features that needs to be extracted from it, and technique that needs to be extracted from it. And my technique should be a best technique such that it has to get all the information without missing any of this one. Then only with the collective of this one, I can train a model, any SVM model, a support vector model. I'll extract all the features, make out a feature vector, and I'll be training the model. And I can call it as a supervised learning, because I know whatever the images I am having, I'm having about 200 images. Out of the 200 images, my classification is all about whether the particular image contains cancer or not. So it is a binary classification. So out of these 200 images, I have 100 images which says this image contains cancer, and another 100 images which image contains no cancer there. So it is an image with labels over there. So I can call it some supervised learning. So I will extract the features from the image one, which belongs to a class one, which I called it as a cancerous image. And then I will give the features to I'll create a feature vector. Similarly, I extract all the features or image from all the images. I try to learn, make my model to learn what are the features, what should be the range of the features to say the particular image contains cancer or not. This is how the machine can be learned over there. So whenever I look onto this machine learning technique, this accuracy of this learning technique will purely based upon what are the features I am extracting and what type of algorithm I have used in order to extracting the features. If I have missed any of these features, important features that helps us to discriminate whether it is a cancerous images or non-cancerous images, then the accuracy of the system will keep going down there. So this is what is said to be machine learning. But this AA, yes, few of the AAs that have been used in the medical industries will also use this machine learning technique in order to predict something. Yes, based upon the data, I can able to predict what will happen, whether that may happen or not. So this prediction can be done based on the patterns, evolving patterns. So whatever the historical patterns are, some of the patterns that I am having it, I will make use of this patterns. I'll also able to predict based on the patterns whether this particular image contains the disease or not. This is one level of machine learning. This is what is called to be a machine learning. When I move on to the deep learning, what I need to do is for a deep learning thing is I need to choose a model. First, I have to choose a model. After choosing the model, I need to look on to my images. But as I told in my machine learning technique, the amount of the images that I am going to provide should be very larger here. Because here in the deep learning technique, I'm not going to decide as a user or as a builder of this any AI, I am not going to decide what are the features need to be extracted. What I will do is, I will just provide all my images, all my data set. I can call it now as a data set because it is not a single image. It might be enormous amount of image of particular classes. For example, again, it is a binary class. As I told in my machine learning technique, my 200 numbers will not enough for my deep learning technique to learn about whether this particular image contains cancer or not, whether it contains a cancer or not. So what I will be doing is, I will be getting more large amount of images in thousands, 2000s, or even it is 10,000 or 20,000. And again, another important point is there should be no imbalance between the class data over there. Yes. So whenever I have this type of images, I'll give this images to my machine, to my model itself. What my model will do is, it again extract the features. And what type of features it is extracting, I am not known to it. It is what is called to be a black box over there. So what type of features are extracting? So I'll be telling that I'll be developing a model at each layer. Yes. So I hope that you have all done image processing. Have you done image processing? Yes. We know filters. Did you know filters? Kernels. What they will do? What they will do? It extracts some features of the images. So I will be using a kernel. I'll be convoluting the kernel with my image, because again, image is again a matrix value. A kernel is again a small filter size with some values inside it. I will convolute it with my image. I will try to extract the features. I have different layers. My complexity of my model increases with the number of layers over there. At each level, at my low level, it will extract the preliminary features. At higher level, it will be extracting the features, very much contributing to the particular application over there. So it gets extracted, keeps extracting the features and try to learn the features and try to discriminate whether this image contains some cancerous or not. This is what is called to be a deep learning model. So whenever I look onto my deep learning model, I need large amount of data over there. There should not be a class imbalance over there. And then the model has to be trained by itself to learn itself about what type of features to be extracted, how about the features, how many features to be extracted, and based upon the accuracy, I keep training my model. And again, I can call something called hyperparameters or hypertuning, where I can talking about how many layers may be there, how many epochs I need to go for that, how about my images over there. It should be a balanced image. I told, no, it should be a class balanced one. I should not say I have about 10,000 images of my cancerous images and about 2,000 images of my non-cancerous images. Then my model will become a biased one. And it always says, whatever I am giving it, it always says it is a positive image only, or it is a cancerous images only. So all these things has to be taken care in my deep learning model. So I'll be saying this deep learning model in the computer vision will help in my medical imaging technique, where it will be look on to any types of imaging. We have different types of imaging, starting from X-rays, CT image, you have an MRI scan image, and you have 2D model, 2D images, 3D images, all type of images. I am able to extract features and I'm able to make my model to learn from the features and can be used for any classification of diseases over there. So I can now combine my deep learning with my computer vision technique, where I can build a better model in order to do any classification. Similarly, these models will not help only in classification. I can also go for any segmentation technique also, because it is in case of this skin lesion classification, he told that it has been segmented. A segmentation process have been taken care. So I have some deep learning models in order to support the deep segmentation also, because learning the entire images and trying to learn making my model to learn is very difficult. So what I can do is, I can look onto my images, find out where my problem occurs. So I can cut out that part of my image, segment that part of image, and I can make my model to train with this part of images very much better accuracy. It will provide me better accuracy. So I can combine my deep learning with my computer vision technique. So I can build a very good model in order to predict, in order to detect any abnormalities present in the medical imaging. Yes. So moving on to the next one. Till now we talked about only the medical images. So I can look onto the images, I can do some classification, or I can do some prediction, I can improve the treatment. All these can be done over there. And what is the purpose of my natural language processing? It is all about now the trend is to automate the report writing. Yes. So given an image, I need to find it out. I need to have the findings of how about this image? What is the difficulty in the image? All these, you have heard about the CT scan report. You can hear about the MRI scan report, all these remote. So what can be done is I can train my model with the image text pair. Yes, where for the image, I'll be using my deep learning architecture, image architecture like CNN, RN, CNN, all these can be used over there, or I can go for any transfer learning technique. In case of my medical images, I need to use NLP technique in order to extract the features from the report also. I need to find out the mapping between the image features and the text embeddings, and then I can make my system to write the report by automatically over this. So that is the purpose of your natural language processing, where it will process the medical records and try to learn from this one. So moving on to the global healthcare challenges. So what might be the challenges? Why we are depending on AI? The first and foremost thing is all about the chronic diseases. We had earlier, we don't hear persons or our grandparents stating that they got sugar, they got the heart disease, or they got some Alzheimer's or something like that. Now, whenever you look on to any old person, they may be saying that they have been affected from either sugar or diabetic, or they may be affected from Alzheimer's disease. If all these organs are right, they may be affected from the Alzheimer's disease, or they may have some heart disease. This is what we will be hearing. Even with respect to my parents, my next level of my generation also been affected by these diseases one day. Why it is so? It is all the long life expectancy leads to these chronic diseases, and the global healthcare says that 70% of the people are living with these chronic diseases, or the death is due to these chronic diseases. All these chronic diseases, which might not be immediately causes any death over there, but it will slowly killing the people over there. So I need to treat the people for these chronic diseases over there. So it requires a long-term solutions over there. So we have a lot of patients over there. So we need to monitor this patient, and all these activities has to be done over there. This is what is the effect of your chronic diseases over there. And then whenever I look on to the next one is all about the rising healthcare and the cost. So nowadays we are not paying for the hospitals. We have insured our thing, and the insurance company is paying that one. So there is a lot more balance. We need to struggle the insurance and the government people, and government are offering more policies where the poor people can be treated over there. Yes. So all these they struggle between the balance affordability with the quality care. That there is a question of quality care. If more people are being trying for this improved health care, then there is a question of quality care over there. So again, this the cost of this chronic disease treatment is also very more over there. There continues to rise there. This rises the healthcare cost. And again, the one and the more foremost thing where I can say I can use an AI, where the decision will not be it cannot be an misdiagnosis or human error, because whenever I say I have taken a picture from, whenever I say I have taken a scan from one particular scan center, my doctors will be saying that, who has been attached with one hospital, saying that I cannot look onto the scan center because the machine has a different configurations over there. So whatever I am looking for, it will not be very clear in that picture. So you have to take it on my cancer center itself. And even when it has been taken in a very big hospital and it has been diagnosed with one radiologist who is present over there, I can take the same picture and look for a second opinion for some other doctor. He might be saying something else. Yes. So there will be an inter-observer and inter and intra-observer difference between there. So it gets to a confusion of what treatment need to be provided over there. So in order to avoid all these one, I can go for a machine where it has been developed with an AI, where it is capable of doing some diagnosis, not the diagnosis, to say what can be taken or any medical consultations. This variability can be overcome over there. So, and then the limited availability of modern medical equipments. The places like the cities, modern cities like Chennai, Bangalore, or something like that, will have all the facilities, and every one of the people can be treated, whether they are poor or rich. They will have their own way of or hospitals over there. They can go get their treatment over there. But when you think of any village or any down south villages over there, so whenever they got some symptoms over there, how they get the treatment or how they will be treated, how this disease can be diagnosed. So we have an opportunity for this one. It is what is called to be the telemedicine over there. So they can get the pictures, send it to the doctors over here, and this doctors can check it out, and or otherwise I can have an AI system built over there where the AI can predict out what type of disease over there, so the treatment can be taken immediately over there. So this is all these one. And then unequal access to care. Whenever I am talking about, again, this is all about the rural and undeserved areas which lack medical facilities. So the treatment will not be same for all people over there. So it helps in the difficulties in the quality and healthcare quality and outcomes over there. So what is needed there? What is the solution for all these one? We need to have an innovation. The innovation states that what type of innovation is needed, because all this traditional, the number of chronic diseases keeps increasing, number of patients keeps increasing, and the treatment for the patient is very much needed over there. So what can be done over there? All these traditional becomes unsustainable due to the increasing demand and cost. So the AI, telemedicine and IoT, all these been developing in a greater way, or reaching a greater heights, that helps us to improve the accessibility, efficiency, and the patient outcomes. So what is the use of, in general, what is the overall thing is, we need to give a good treatment to the patients, then improved treatment to the patients, and we need to look after them in a very good manner. This is what is needed for everything. So as I told you, the AI cannot be done as a separate thing. It needs some innovations over there. So what is that one? It is all about the data. How about the data? What type of data is that? On what quantity of data is being available? All these matters how my model will work over there. So we know that we are living in the digital era where we can have different types of data can be available over there. Multimodal data can be available. So whenever I look onto this multimodal data, I can say with respect to the medical industry, I can say it is the genomic data. It is all these diseases can be related with the genes, yes, or the DNA molecules over there. So I cannot be treated as such. This is the symptom, so I am just giving this medical. We need to have a personalized treatment also. This all depends upon what type of genes that is being affected by, that is being simulated by this disease, or how I can control this gene. All these all over there. So we have a genomic information is needed, and then the economic status of the patient is also very much needed, and demographic information of the patient, whether what is his age, from which area, from which country he is coming from. Because as we have already discussed, we will not be affected by the skin disease, but our foreign countries like in US, UK may have lot more of skin diseases over there. So all this demographic information is very much needed. And then you have the phenotypic data stating that if I am saying that this is the disease caused, or this is what is the disease, I need to look on to the symptoms of the disease. Yes, and also the side effects of the disease. So all these has to be noted. So all these informations are available, and the availability of this multimodal data helps us to make my AI to be trained with any special functions or any special treatment or diagnosis there. So apart from this one, I also need a technological innovation such as IoT. Yes, we are now living with 5G. Yes, so we have a lot more mobile technology and Internet of Things, and we have a computing facilities. Now, earlier we were talking about CPU. Now we are talking in terms of GPU. Yes, what is GPU? Graphical power processing unit. So which helps us in the computational advances. So all these, and also whenever I'm talking about the data, I need to look on to the security of the data. Yes, I should not relay, the data should be a secured data stating that I should not release the name of the person or the name of the patient or any other information to anybody over there. So data security is also very much important over there. So all these are also be available. So this makes my AI to have a greater impact in my health technology. And I can say why it has what makes this transformation? Because we have available n number of, it is possible to have a great computing technique where I can do a large amount of data processing with the help of the medical data processing. And also it is also possible for me to use advanced pattern recognition techniques in order to have a faster and personalized treatment for the particular patient. So all these makes us to move on to there to develop an AA for this. And this is what is the role of AA in healthcare. Yes. So earlier we all people were wearing a wristwatch. Now what type of watch most of the people are wearing? Smart watch. What it will do? What type of information will be collected? Where it will be going? It detects the heartbeat. Yes. Why we need to detect the heartbeat? What will happen to us if it has not been detected? Yes. What will happen to us? Why we are bothering about the calories? Why we are want to burn the calories? Why we are looking onto the steps that have been walked throughout the day? It makes it healthy. We are not looking for the health. I am just wearing the watch. I never look onto all these information. It is only the collection of data where that makes my AI to be more powerful. Yes. So all these are the collection of data only. Every year, our college people will have one medical checkup. We never say that we got checked up. We always used to say, but our data has been shared. Yes. So always it is only the collection of data. All these makes our AI to be very powerful. That to be sure. Yes. So starting from the digital health monitoring to clinical end-to-end solutions, there are some cases where this can be used as an entire solution over there. And then I have the drug discovery, as we have discussed earlier. In our COVID cases, many new drugs or many new vaccines have been invented. This has been done with the help of the AI. And then image analysis software, as I told you, it helps us to diagnose the disease from the, or it helps us to detect the abnormalities from the medical images such as CT, MRI, or anything. And then nowadays it is more famous, which is robotic assisted surgery. No surgeons are doing the surgery alone. They are doing with the help of the robotic assisted surgery. Even a gynecologist is also working with this type of robotic assisted surgery only. So what is the advantage of doing with this help? Or will that impact that is what is the impact of the AI? We need to look onto it. And then we have a personalized treatment. As I told you, that we need to look onto it. If I have identified some disease, yes, I cannot be given with a common medicine or something like that. Yes, depending upon how I am responding to the medicine, how my body responding to the medicine, and what is the side effect for it, I need to choose on, I have to be given with a better dosage, or I have to be given with a lower dosage or something like that. That can also be decided by the AA. Yes, and then the readmission and risk prediction. All these are considered to be the role of AA in healthcare. So among this one, these are the places where the AI has a high revolutionary in healthcare or helps in improving the healthcare. The first one is what is called to be the drug discovery. So whenever I say I have been affected by some disease, the basic behind this disease is all about the proteins linked to the disease. So I need to identify the proteins. If I need to identify the proteins which causes the disease, I need to know about the genomic and proteomic information of my disease. Yes. So there is one AA that have been available, which is what is called to be DeepMind's AlphaFold, which predicts the protein structures that is being present in our body. Yes, how it is doing it? It make use of a deep learning architecture. It make uses of transformer architecture of the deep learning model. And then it helps us to detect the protein structure and helps the researchers to understand the disease. Once I understand the disease, or once I understand which protein contributes to the disease, I can able to find out the drug. Yes, new drug for the disease based on the protein structures. Yes, so that can be done. So this one make use of generative models. What do you mean by generative models? What do you mean by generative models? Yes. Can you tell me one generative model? ChatGPT is a generative model. Why you are saying it is a generative model? Yes, if it is able to generate something is in the form of the text or something in the form of the image or something in form of any modality, I can call it as a generative model. Yes, so this generative models helps us to create compounds because I needed drug compounds. These drug compounds is purely based upon the protein structures of the disease. So I need to study about the protein structures. This can be done, and a new protein disease, new drug will also be done or designed based on the understanding of the disease. Yes. And then the next one, it is what is said to be the atom-wise A. So, in order to find out any new drugs, I need to know about the molecular interactions or the chemical composites that behind this one of our thing. So, I need to have this one, this atom-wise AA, which is capable of screening 10 million compounds in a day. Yes, which might be really larger than that of any human can do it. So this reduces the research time. Yes, so this is one thing which speeds up the visual screening, this atom-wise AA. And then as you people have discussed about IBM Watson Health. Yes, so this is given by the company of IBM. These people, what they are doing is, once this drug have been discovered, I need to make a trial of the drug to the patients, particular patients. I cannot provide it to the market. Before that one, it has to undergo some trials. Yes. So what this IBM Watson Health will do is, it analyzes the millions of records. That is, when a healthcare record been analyzed and find out the suitable person where the drug that have been discovered can be given as a trial. So I have to discover who are the patients that have been affected by this particular thing, and then I have to give them as a trial one. So the clinical trials by predicting the patient responses, dosage, and reducing the cost. This is how it is happening there. And then I have another AI which uses a machine learning technique which says which patient is the suitable person to undergo this drug. So it is all purely based upon the health records that have been stored there. Yes. So the next one, once that drug have been discovered, so what needs to be done? It has to be given in a trial. I cannot directly give it to a human people. So it stimulates this in silo medicine that make use of an AI where it stimulates a human body or human features, where it can be given there first and look onto this trial. It can be given this drug and we'll look onto the drug effect for the simulated human, and then it can be given as a trial. So what is the use of all these drugs, all these AAs that have been present in the drug discovery? All these, because we are looking for a new medicine. We are looking for the new compounds. You are looking for the new combination of, based on the protein structures, I am looking for the new combination of medicines, compounds over there. All these reduces, this AA helps to reduce the research time. I cannot go for an trial and error methodology. Yes, I cannot waste my time. I cannot do with some experiments and come to a conclusion that this will not work out. All these things can be avoided over there. So reduces the research time and cost by improving the, it identifies what will be the target compound that can be combined together to form the new drug over there. So drug efficacy modeling can be happening very faster with the help of these AAs. This is what is the usage of these AAs in the drug discovery. And then when I say it is all about the personalized treatment plans. So all these treatment, it has to be personalized for all the chronic diseases, because I keep eating the same medicine for a number of years. What will happen? I will get some side effects over there. Yes. So in order to avoid this one, everyone can have a personalized treatment plan. Yes. When you look onto any diabetic person, when they are meeting the doctor for every 6 months or something like that, they will check on their blood level and keep changing their medicines. Yes, the dosage level may be increased or it can be decreased, or based upon how they are deciding it. It is based upon the genetic makeup, medical history, and lifestyle of the people. So all these to be taken into considerations in order to provide the dosage level to the particular persons. So this is what is called to be the personalized plan. So I have a one specific AI which has been released by IBM Watson, which is what is called to be in IBM Watson for oncology, which recommends the cancer treatment. This again, whenever I'm talking about the cancer treatment, we have different phases of cancer and different stages of cancer, and each has its own treatment over there. So whenever we go for any chemotherapy, what will happen? Even my good cells will keep dying or will be killed by that chemotherapy chemotherapy. So it recommends the cancer treatment based on the genetic markers. So which contributes, which genetic genes have been contributing to this particular cancer. So I need to identify the genetic marker first, and then I need to find out a drug which can affect only that particular genetic markers where I cannot be affected by the cancer hereafter. This is how what is being done. So this is what is the use of this IBM Watson for oncology. And again, once I have been affected by cancer, I need to decide on the therapies. So what do you mean by therapies here? The therapies can be of a targeted therapy or a immunotherapy. Whenever I am saying it is a targeted therapy, I need to identify which genetics contribute to this part of the cancer. So I need to identify it. I need to kill it. So that is what is called to be the targeted therapy. Yes. And you have something called immunotherapy, which will help us to improve my immune system. It's what is called to be the immunotherapy. So based upon the right combination of the therapies can also be checked out with the help of the AI, which is being done with the Tempus AI. Tempus is a company which been providing many different which building many different AIs. One such being released by Tempus is what is called to be a Tempus X. Yes. So with this Tempus X, it looks on to the DNA's sequences of the DNA cells and helps us to matches the patient with the what type of patient that can be used for this similar genetic mutations can be decided over there. Yes. So the next one is all about the whenever I look onto the cancer being predicted with the help of your blood cells itself. It is what is called to be the pathology images. So in this case, you have a particular AI that scans the pathology sites very fastly than a human can do it. So you have one particular AI, which is what is called to be path AIs, which can predict cancer with 99% accuracy, reducing any diagnostic errors over there. Yes. And then whenever I say, what is the use of to have a personalized treatment? The one is I can reduce the trial and error methodology treatment over there and improve the treatment success rate and minimize the unnecessary side effects over there, because I'm very specific about what type of, I am just looking on with what type of genes contributing to this one. I am trying to kill the particular genes over there. So unnecessary side effects will not be there. And then any decisions can be made on the data driven by the oncologist. Decision can also be made up onto this one. So moving on to the next one, next important role of AI is all about the patient monitoring and remote care. So as we have already discussed about this one, the one is the wearables powered by AI. All these wearables, we can say it is an Apple Watch, Fitbit, or other things. All these, what is happening? They are collecting the information. What happened to the collected information? Already an AI has been built onto it, which has helps us to monitor the heart rate, yes, oxygen levels, and also the ECG data. Yes. And then moving on to the next one, it is all about the health. So I need to predict the disease before it affects me. So that is what is the use of all my patient monitoring and remote care. So what I can do is I can process all these data that have been collected through the sensors, and these data based on the patterns that have been recognized, I can look onto it what type of disease can be affected by what type of disease can be affected. So I can provide a alert to the healthcare. Yes. So this can be done. You have one specific one, which is what is said to be biointel iSense, which helps us to monitor the respiratory rate, temperature, and heartbeat. Okay. So this is one specific AI over here. And then whenever I look onto the patient monitoring and remote care, meaning that the patients may not be present in their hospitals, maybe at the home. So all these vitals has to be daily monitored and it has to be checked out. So the round the clock, the monitoring has to be done, and you have to get the advice from the doctors, and recommendations for the medications has to be done over there. So we have something called Babylon Health, which analyzes the symptoms. So it provides the solution based on the symptoms. So it analyzes symptoms and recommend the medical consultations. It may say, these are the symptoms, so you may get cancer or something like that. Some recommendation based on the symptoms that have been analyzed. So it is, what is this one? Babylon Health. And you have something called Care Predict AI, which helps us to look after our elderly patients. The purpose of this one, it detects the movement or the steps that have been taken while walking or something like that, so that it predicts the fall of the elderly person. Yes. So that is what is this one. And apart from it, we have some social robots that helps us, the individuals who have been affected by autism and also depression, dementia, all these through an interactive support. All these we have supported social robots, meaning that robots with AI have been present day. Yes. So all these will help us to have a continuous patient assessment, reducing the hospital readmissions, allowing the independent to live with the real-time monitoring benefits. Yes. So the next one is all about the chatbots. So when I am talking about the chatbots, as that of the physical health, what is to be called mental health is also very much important. So we need to monitor. Some people will be affected by depressions. Yes. So they need to be treated. Yes. So all these, we have something called the Webot AI. Yes. Where it can provide suggestions or support this one for cognitive behavioral therapy. So this is one thing over there. And apart from it, you have Amazon, Alexa together. It is one such AI which have been powered, and it is able to communicate, able to provide you as a voice assistant, AI-based voice assistant. And it may be called as a smart home assistant, and it gives the elderly people, or it can monitor the elderly people and give any alert to the caregivers over there. So these are these different AIs. All these enhance the patient care, and also it able to detect analyze the symptoms and able to give the alert to the caregivers over there. Yes. Yes. Apart from it, one another thing I can say, this AA has also been found in your hospital management too. Yes. During your COVID cases, we have been left over with no beds have been given, have been present in any of these hospitals. So we face so many deaths over there. All these been monitored, and we have AA to look on to the patient scheduling, so that the time of the patients cannot be wasted over there. So based on it, predict the patient volume and optimizing the schedule. And also it is possible for us to driven on the resource management. Whenever I'm talking about the resource management, it forecasts the staffing and also the usage trend. Based on the usage, it talks about the supply usage trends, predicts the supply usage trends, and also there is efficient AI tools to support or to ensure the bed occupancy management too. Yes. So where this AI is being used in the hospital workflow patient, and then looking onto this robotic assisted surgery. So I have RAS, the robotic assisted surgery, meaning that it combines the artificial intelligence with the robots, robotic systems. What is the purpose of this one? It is all about the precision, control, and minimal invasive procedures. So the one thing is what is said to be Da Vinci surgical system. So this is the system mostly used in case of the prostate cancer surgery, because why this been using, with this being the prostate cancer is being affected for an elderly peoples, while those been in the age of 70, 80, they have been mostly affected by this one. Yes. So whenever it been in different stages, it has to be removed. And it is very dangerous. It makes some nerve preservations has to be done over there. Yes. If not, it will affect our urinary tract over there. So in order to do this one, this system have been used, and it was very much successful in order to do the prostate cancer surgical system, where it can be used for a prostate remover, and where it provides a high precision and better nerve precision over there. So loss of blood and affecting of different nerves that may be around that one will be avoided by such type of surgical systems. Yes. And then you have this cyber knife system, where people undergoing radiation therapy can also be altered with this one, this real tumor movement. Based on the tumor movement, I can adjust the radiation therapy. This can be done by the cyber knife system. And you have this one, where I can say it is purely basically working for the lung cancer profiles. This is Johnson's Monarch platform. So all these helps for the can be called as a robotic assisted surgery and helps in some way for the patients and also to the medical experts. And then the last one is all about the medical imaging. So whenever I talk about this medical imaging, I can look for any disease diagnosis and also look for a treatment planning and patient monitoring with the help of the medical imaging. Yes. So what are the more common modalities that have been used in the medical imaging? One is what is said to be the X-rays. The other one is said to be the magnetic MRI, the CT, ultrasound, and PET. So these are the different modalities that have been available. And it is possible for us to predict the diseases or predict the abnormalities that have been present in any of these modalities. And we have different types of models that have been available now in order to predict or diagnose the diseases from these modalities. So this advancement helps in the improving the speed, accuracy, and accessibility. That is what has been taken as an advantage of having this one. Yes. So the first case study, what I told you is all about. I can able to say that this deep learning models helps us to make the decision or helps us to give the decision in a more efficient way. Yes. So that is what is this one. Whenever I'm talking about the coronary artery disease, it is nothing but it is a type of a cardiovascular diseases. Yes. So how it happens, it is due to the deposition of the plaques or the lesions in your coronary artery. So we have the coronary, we all know that heart is the one that is pumping blood to all parts of the body. But to the heart, the one that is pumping the blood is what is called to be the coronary arteries. So if the coronary arteries have been, these coronary arteries have been affected by any plaques or lesions, so what will happen? These depositions narrows the blood flow into the artery, which makes a narrowing or a sudden blockage over the coronary artery, which is what is called to be the stenosis. Yes, all these stenosis will lead to the heart attack. Yes, this is how heart attacks occurs over there. So it will not happen in one day or two. It will happen in course of time where this type of depositions may be present over there, and then it blocks the flow of the blood into the arteries, and which leads to the heart attack and due to the reduced flow of blood to the heart muscles over there. So this is what is what is called to be the CT slice. Our aim is to develop a solution in order to identify the stenosis from the 2D images rather than moving to the 3D images. This is what is my PhD work. I have done my PhD work in the year of 2016, where our aim is to do the stenosis analysis in the CT images, in the CT 2D images. But what are the problems that we have faced during that one? So whenever I'm talking about the 2D slices, I can get about 150 to 200 slices of a single patient for a heart. It is the imaging of the heart. So it will be in the form of the slices. It will be in this axial form where I'll get, where each part of the slices have some content of my heart present in it. Yes. So when you look onto this, this is what is my coronary arteries. I have sliced it in this way. So what will happen for each slice? Some part of my hand will be present in it. So of this 150 to 200 slices, my coronary artery will be divided into slices and it will be present in the CT slices over there. One important thing is this coronary artery will not be present in all the slices. As I am saying that it is all about 150 and 200 slices, this will not be present in all the slices. So what I need to do is to make it in an efficient way. First, I need to identify in which slices my coronary arteries are present or not. Yes. So while I am doing my PhD, I started with this work of identifying my coronary arteries where my AAs are not been very empowered over that time. So what we decided, we thought of doing it in a machine learning technique. And it is not possible for us to work in the 2D slices there, where we go for some other imaging technique. What is called to be axial slices of CT art. How it will be there means it is not a 3D. Again, it will be 2D, but entire structure of different positions will be given to us. So I will identify my coronary artery in each of these one, and I have to come to a conclusion. All these points will represent one single point, and then I say I have to locate in my original image where my coronary, my stenosis is present or not. This is what is the difficulty I have faced to at that time. but we did it in the coronal axial slices. And what we did is we used a medical image processing technique. We extracted the features. So what we did, we started with the starting point of my coronary artery and used some algorithm to track the coronary arteries. And then we extracted the features from the coronary artery, given it to an ESVM, and we identified at each point whether the stenosis is present or not. This is how we completed our thesis. But due to the development of our AI system, we reworked on the same paper where we have decided to work on the 2D slices itself. So I hope that you have understood what is the picture of the slices. So if you think this is what is one coronary artery, the CT, what it will do, it will give the slices. So each slices will have some part of my arteries that is present over there. So I told that this is all about 150 and 200 slices. And the heart will not only have the coronary arteries, one important organ, you have some other thing like ventricles, aorta, that may also be the part of your slices there. So what we decided, we first thought that we can identify where the coronary arteries is present in each of the slices, or whether the coronary artery is present in each of the slices or not. So we thought of going for some classification algorithm, where my classification algorithm will take one slice and have to classify whether the corresponding slice contain coronary artery or not. Yes, whether it is present or not, it is a binary level classification. So this is one point that we have decided. So we thought of going for any image feature extraction. The one thing that will help you is one simple model, which is what is said to be convolution neural network model, which will be able to extract the features. Can you know about what is the architecture of a simple convolution neural network model? Yes. It is you have the convolution layers, followed by it, you have, what is that one? The next one. You have max pooling layer, you have convolution layer, and you have a layer where it will convert all your features into non-linearity features. You have another layer. I will check it out and let you know what is the next feature, next layer that may be present. And you have a max pooling layer, and then you have a fully connected layer, and then I can have any classifier over there where it will classify the inputs that have been obtained from the fully connected layer. So this might be the layers of my CNN. What I can do is, based upon the complexity of my applications and based upon my information to be extracted, I can have different blocks of these convolution layers. There are different blocks of this layers over there in order to extract the features. So the first layer will try to extract the preliminary features like edges, colors, textures, or something like that. As I go higher up in my hierarchy, it will extract most extracted features from it. So all I can do is, I can use a coronary artery and extract the features from the coronary artery, and I can say whether the coronary artery contains, whether the slices contains coronary artery or not with the help of the CNN. But there is some sequencing information that might also be present, because if this slice, whenever I do it as a slicer, this information is being spreaded over throughout the slices over it. So I need to have some sequential model in order to extract the sequential flow of the information that is present in it. So we identified that we can combine the two models. One is what is called to be the CNN model, which extract the features from each of the slices. The other one is what is called to be the RNN model. RNN is one special type sequencing model where we have used LSTM. Yes, can you know the expansion of LSTM? LSTM? Huh? Can you know the extension of LSTM? Long term memory. So what is the purpose of this one? This one will get the sequence information that may be present in it. So the extracted features been fed into my LSTM model, where it will get the sequential information, and these two information will be combined, and this will be given to a classifier, where my output of my classifier will be the binary classification, saying 0 means my slices doesn't contains coronary artery, saying 1 means my slices contains coronary artery. So my output will be, this is what is, it's a supervised learning. So I am trying to learn this one. So I have a slices, I have specified my labels to the slices. The label 0 refers the particular slices doesn't contains a coronary artery, and label 1 refers the slices contain a coronary artery over there. Yes, so I'll be training with a set of images. I will be training to the CNN LSTM model, where I'll be extracting the features along with the sequential information, and I will be able to predict whether the particular slice contains coronary artery or not. Once I have identified and filtered only the slices that contains the coronary arteries, I keep moving with my next part, which is what is said to be the segmenting the coronary arteries. As I told you, the slices doesn't contains only the coronary arteries. It also contains other part of the heart information also. It may be present in the slices. So I need to filter out all other informations. I have only the coronary arteries that have been identified to be segmented out of from the slices. So we gone for the another model, which is what is said to be unit. Unit is has a good performance in the segmentation with respect to the medical images. And again, this unit model will have two parts. One is what is called to be the contracting path or the encoder path, and you have a bridge that connects the encoder path and the decoder path. So, and you have the expanding path over there. So whenever I'm talking about the contracting path, where the convolution layers will be used over there, it extract the features and try to reduce the dimensionality features, and it fed it to the bridge over there, where the bridge will get some high complex features from the images, and it will be present over there, and all these will be moved on to my expanding path, where my transposed convolution layer will be used there, and it has been expanded to the dimensionality that have been reduced in the corresponding path. And you have some information that will be provided from the contracting path to the expanding path. With making use of these information, and my unit is capable of segmenting the coronary arteries also. Yes, at each during the training, what I will be doing, I will be giving the slice, and also I will be providing the ground truth to say at which position the slice is present. I will give the mask where the coronary artery is present in this. During training, it trains along with the image and with the corresponding mask of the image. So whenever I give a test image, it try to provide me the mask, binary mask of saying where is the coronary artery is present in the particular slices over it. So this part says whether the slice contains coronary arteries or not, and the next part says it segments the coronary arteries out from the obtained slices, and then all these coronary arteries have been stacked upon, and we used an MIP, like maximum intensity projection algorithm, where I have constructed a 2D from the 2D slices at 3D arteries over there. Yes, so this is the process that helps me to remove all my all the parts of the heart, and I obtained a 3D structure of my coronary artery over there. So now what I can do is, I can again give it to SANN model and do the analysis on the structure, and I will say where the artery is present over there. Apart from it, I can also do the grading of the stenosis, saying that how much is it an obstructive grading or a non-obstructive one, saying that obstructive is a higher percentage of narrowing down and non-obstructive is a lower percentage of narrowing down. So there is a possibility where the non-obstructive stenosis can be developed into an obstructive stenosis. So I can do the diagnosis, and also I can provide a solution for the patient, whether they can go for a stent or whether they have to go for a any other treatment regarding with this stenosis. This is one paper where I can say how AA have impacted or how I have changed my work within 5 years. Yes, I've started with the machine learning technique, and I obtained a very low accuracy over there for using for the machine learning technique that I have did it. But I have did it as I decided on in order to make it as a very cost effective, because at that time taking a 3D image like MRI is very costly. So we thought of working in a 2D image slices itself, and so we have improved our system, and we have used a deep learning model, where this deep learning model within 1 second it will able to detect the coronary arteries. Apart from it, it is able to slice down the segment the coronary arteries and able to reconstruct the coronary arteries over there. Yes, so this is one work that we have done, where I can say we can clearly look onto the impact of AA in this part. And then, so as I told you, this is all about the segmentation process. So I need have a performance metric, which is what is called IOU. So intersection of union. So what I will do, once I have segmented the coronary arteries, I will check it, intersect it with the ground truth and find out how much percentage it has been intersected with this one. I obtained a score of 84.36% for my coronary arteries there. Yes. So this one, I can say I have reduced the manual errors here, where inter and intra variability, observer variability can be resolved here. And then I can use it this model where given a slices, it can give you coronary artery, 3D artery, where my doctors can look, sit it in the system itself and look onto it and find it out whether stenosis are present or not. Yes, that can be done. Yes.
Participants, after 5 minutes of time, we will have the tea break. So till that time, we'll just remind you, 1 hour before I told that templates are there, do check and tell us whether it is accessible or not. So that time, 1 or 2 participants told that it is not there, we have put. So you can have a check on that.
Hello? So, okay.
Share that link once again. The templates are, there are 4 folders. So in that 4,
so there are 4 folders there. I think article summary, all of you are done. Only I think Dynamo group 1 report I saw. So please put the other one also, article 2 report. And there are 3 more folders that you have to complete. One is experiential learning, that is with all your demonstration, hands-on, case study, all of it will fall into experiential learning folder. Then that is individual. Okay, that is individual. That's why I've created groups. There are folders, subfolders inside. So each group, like whichever group you belong, in that with your name, you save the report. Okay. Then industrial visit is going to be a group report. So tomorrow, please do not forget to take a group photo with your 6-member team. Take a group photo with wherever that industry name is visible. Take a geotag photo as well. Okay. Don't forget that tomorrow when you go. So that is going to be a group report. Then we have one more report, reflective journal. So that is again individual. Okay. IV is group, article is group, experiential is individual, reflective journal is also individual. Okay. Yeah. Yeah. Okay. And every folder, there is a template which will say the format how you have to fill. Is that okay? Need not wait till Saturday, even evening after reaching home, individual reports you can start doing. Fine.
So, good afternoon. Good afternoon, everyone. No, it's fine. I'll use this. Uh, so, good afternoon, everyone. Myself, Angel. So, we are from Team 5, Eclipse AI. So, I'll be presenting about the revolution of MRI in AI analysis. The company name Addison's, which like how they have chosen the MRI scans to like revolutionize the things. So, like, so first about the company. The company is based on the AI tech where they usually analyze the algorithms and input the data values to the algorithms and feed the algorithms. They use different algorithms like conventional neural networks and RNNs and transformers where they literally train it continuously again and again so that the algorithm gets used to it. And they are being tested to ensure its accuracy, robustness, and generality across the different populations. And how it is carried out. First one is automated segmentation, where one person is trapped into the MRI system, and the MRI, the radiology, is happening to the entire process of the human body. And each segments, like if there is any ligament tear or if there is any broken bone, everything is like seen from the automated segmentation, where everything will be detected. Like for brain imaging, if there is any damages or like specific region has any concussion, it'll all be displayed. And next one is quantification, in that where all the images are like processed and they add like the see the degree of tissues are being damaged, and they make sure how accurate these things are and assist and monitor these diseases. Next one is reporting and visualization, where this MRI scanning, which I know the things which they find in this MRI systems, they will be added or like formed into a report or communication to the healthcare professionals. And interrogations, where mostly the hospital where they integrate into the MRI system, where they use PASC, that is picture archiving and communication system, to the hospital system, where they get the imaging faster and they ensure that it is proper. So now the session will be handled by Nawaz.
Good afternoon, everyone. I'm Nawaz. So mainly I've talk about the areas focus on based on AI. Basically, in the medical system, we focus on AI system basically on neurology. What is neurology? AI can assist the diagnosis, monitoring, and neurologist. Like conditions, it is based on for brain. We analyze the by, by doing the scolarization, multiple scholarize. By with the help of it, we can analyze it and we will perform musculoskeletal imagining with the help of MRI scanning. We will check we can scan the joints and the muscles where we find the ligaments, assisting diagnosis of injuries which are present in the body. And the third one, anthropology. Well, audience is known for lung cancer solutions using CT, like CT scanning. MRI scan mainly analyze can also be used in detection and categories of tumors other parts of the body. These are the mainly challenges of traditional MRI analysis. It's like generally it is a time consuming process, and potential of human error and variability is imperson, increasing workload for radiologists and contributing to burnout, lack of standardization, reporting for communication. Conclusion is, with the help of AI, MRI analysis will be going on. With this process, we come to conclusion that by the help of MRI, like we can get easily by the time, within the time, we can get more results. Thank you.
I have one question. What kind of output does this tool give? Is this a tool or is it a software that is given? So the output is a text report. Image. Ah, yeah. So in the MRI image, it will be embedded like where the problem is, or is it a separate report? That is. Okay, good.
So thank you, Group 5. Now I request Dr. K. Kalaiselvi, Coordinator, Computer Science Department, to come and brief about tomorrow's IV. So ma'am will be accompanying, or someone deputed by ma'am will be accompanying the participants to the IV venue. Okay. Ma'am, you can.
Good afternoon, dear participants. Tomorrow, we'll be going for an industrial visit to a very well-known company called Click. It is actually QLIK, but we pronounce it as Click. They are the leading BI company, business intelligence and data analytics company. Okay, they're basically German-based, but their branch is in Kalyani Solitaire, that is Panduranga Nagar. Okay, at hardly 11 kilometers, 11, 12 kilometers from here. Okay, so the bus will be leaving by 12:30 from here. And then almost with the traffic and all, maybe we are estimating 2 or 2:30, we may reach there. Before that also. A session will be there in the Click office, approximately for 30 to 40 minutes, and then maybe 1 hour. Okay, so we'll take off from there by 3:30, and then we'll reach. The traffic is more in the evening, so maybe 5. But anybody wants to get down in between, your places are there, please let us know, we'll drop you there. No deviation, but on the way we can drop you and we'll reach KJC here. And please take your college ID card and the participant ID card also. Okay, so entry is with the ID card only. Okay, so if anything is there, you can ask them also, because they are more proactive to have us, and then you can ask any doubt regarding the sessions related to BI or analytics over there. Thank you.
We'll start again with this one. The case study that I am going to take is all about the skin liaison and segmentation. I hope that few people have already explored this one. The one thing I want to give you the clarification that cancer is not a contagious one. Yes, it is not a contagious one. This is due to some abnormality that is present in the skin. Normally, the skin cancer will always be predicted with the help of the dermoscopic images. It is one type of modality that has been available. All these CT, MRI, all these images is called to be invasive in nature, meaning that for taking a CT, I need to inject some iodine into my blood so that the path in which the iodine moves on, it gives me a clear picture of the imaging. Yes. And similarly, the MRI, it is all about the rhesus, which also affects the body. But in case of my dermoscopic images, it is a non-invasive methodology in which it has been taken where no third-party chemicals will be injected while taking this dermoscopic images. Yes. So that is what is this one. So when I look onto this dermoscopic images, I can scale some abnormality that is present in the skin. And these abnormalities keep going. Why I am saying it is an abnormality, it may keep growing that affects the part of the skin over there. So whenever I'm talking it, there are different types of skin cancer. The one and the foremost essential thing that needs to be diagnosed is all about the melanoma. Melanoma is considered to be the most dangerous skin cancer. The non-melanoma things, all other things can be considered to be the non-melanoma things. So these are the type of skin cancer where some may be very strong enough to become a cancerous cells and some may not be a cancerous cells over the period. So this is what is all about this one. So I'll be talking about all these cases where all these meant for only two purpose. One is how I am doing the segmentation. Segmentation meaning taking out the lesions from the skin images. The other one is how I am classifying this one. And most of this classification, what I am going to talk about is all about a binary classification where I think in one paper I have discussed it with the multi-level classification. Yes. So the first and the foremost thing, this is what is the paper that we have worked in the year of 2018 after my PhD work. It is all about the automatic segmentation, skin liaison segmentation of dermoscopic images using graph cut and K-means algorithm, where we have concentrated only in the segmentation process, not in the classification process. So what we did is, yes, we used the semi-supervised learning. So we all know what semi-supervised learning is all about. So we have some part of information which is what is said to be the labels have been present, and the other part of the information where no labels have been present. We have some unlabeled information that might be present in it. Making use of this labeled and unlabeled information, I will make my system to learn over there. This is what is called to be the semi-supervised learning. Why I am calling it as a semi-supervised learning? I am calling here as a semi-supervised learning where I have this system needs some interaction from the user in order to do the process as automation process. Why? That's why I'm calling it as a semi-supervised learning. So the purpose of this one is it make use of two things. One is what is called to be the graph cut algorithm. The other one is what is said to be the K-means clustering. So the aim of this work is to segment the lesions from the skin images. So as already discussed in the morning, some pre-processing we have taken, and n number of open source data sets are available for the skin cancer. ISIC is a consortium. It is an international consortium where skin images of seven different subclasses have been present in the skin classifications. All these images have been available, and you have the different versions of ISIC. One is 2017, 18, and you have another version at 19, and lastly they have published at ISIC 2020. So you can collect I don't remember the number of images present in each and every classes. It is freely available. You can download and you can use those images for your research work also. The thing is, one is what is called to be the pre-processing. When you look onto these images, I think somebody has already shown. This is what is out of the skin liaison images. So whenever you look onto these images, the skin lesion may consist of some artifacts that might be present in the images. The one thing, it might be have some noise present in the images due to the sensors that have been used in your camera to capture the images. So I need to remove the noise. So noise removal has been taken place over there in order to improve the image quality. That is one important pre-processing that we have done. Apart from it, the another important thing is the hairs, presence of hairs that may also affect the performance of my system. So I try to remove the hairs also. For that one, we have used some Fragni Vesselness methodology, where we will be training the system with this flag, and then we'll try to remove the hair from out of this one. So this is one thing that have been done. And apart from it, some illumination corrections have also been undertaken over there in order to remove uneven illumination of image effects caused by the sensor faults. So these are the three different pre-processing that we have done. Once we have done, the input images have been pre-processed and our images are free from artifacts that have been present in the images, and it is considered to be enhanced images. And out of this one, what we are trying to do is, you have lesions. Whenever I say the lesions, when you look onto these lesions, you can look onto them thing that it is not of a regular shape. It is of an irregular shape. That is one thing that is being present there, and it is considered to be the most important thing that needs to be considered whenever I do go for a segmentation. So whenever I use a unit mask or something like that, what I have told in a deep learning architecture, I need to prepare a mask for the system to train, because it is a supervised learning. So in case of my any segmentation deep learning model, what I need to do is, I need to say what is the input and what should be the output of the input. That is, if I am saying the earlier stage, I showed you a coronary artery. So in the slices, if there is a coronary artery, I need to have a ground truth stating that this is what is the coronary artery that is present in it. So with the help of the input and the mask only, the system keeps learning during the training, and during the testing, whenever I provide the system with any input image, then it will give me the segmented image over that. And similarly, when you look onto this one, these abnormalities are found to be irregular in shape. Yes, and then they have a different colors that may be present in it. So making use of these two things, these two characteristics, I found that this might be the most challenging thing to do the segmentation present over there. So we used a graph cut algorithm, where we have already done with the graph cut algorithm in our data structures, where it is consists of nodes and edges. So what can be considered as a nodes here? It is nothing but the I want to first segment out the foreground and the background. The foreground, what I am considering is the lesions, and the background is nothing but the normal skin areas, is what is considered to be the background here. So we used this graph cut algorithm, which works basically with the directed graph that established between the sink node and the source node. Source node is considered to be the foreground, and the background is nothing but the sink node over there. And we provided a weighted average between these two things, the edges between these one. These weighted average is purely based upon the probability of how about the cells where it belongs to. Yes, this is how we have done this one, and we have identified the foreground area and the background area. And it is not possible for us using the graph cut algorithm to extract the exact structure of the skin lesions out of the images, because it is a pure image processing technique that have been used there. So this refines the segmentation but reduces the false, but I have not found any defined edges. So it is not possible for me, due to this irregular edges that may be present on it, it is not possible for me to extract it very clearly. So what we have did again is, we want to refine our segmentation process. We went for an unsupervised learning, which is what is called to be, we have used a K-means clustering. So what do we mean unsupervised learning? You don't have the labels present. So what we did is, once the foreground have been extracted from the images, we want to again divide it, because as I told you, it is not to have a perfect edges, and I have some part of the background images might be skin blue normal skin layer areas that have been present in this one. So we used a clustering algorithm, K-means clustering algorithm, and divided into three important and formed 4 different clusters. It is the normal skin region, Apart from it, the interior part of the lesions, the boundary of the lesions, the area in which there is a merging area where the skin boundary and the normal skin, the lesion boundary will also merge over it. This is how we try to cluster it. So we used an RGB color space and we try to cluster it based on the color intensity of the images that may be present there. And we identified all these lesions along with the boundaries where we have merged it using some morphological operators where we obtained a perfect edges of the lesions, and this is how we have done our segmentations. This is what is our paper that have been published in the year of 2015, not 2015, it is about 2018, where we used as unsupervised learning methodology in order to do this one. Yes. So later what we did is we used the same unit architecture in order to do the segmentation process, and we also obtained a better results in the segmentation process, and we went for the classification in order to classify that one. Yes. So this is how this is being done, and we have some performance analysis metric in order to do this one. We have used two different data set. One, as I told you, ISIC 2017. The other one is a PH2 data set. This PH2 will have some lower, lesser amount of samples, but this ICICI have some larger amount of samples for 7 different subclasses that may be present in the skin lesions. And we found the dice coefficient value of 0.82 for ISIC 2017 and 0.91 for the dataset of PH2 dataset respectively. This is what is our performance metric or performance that we have applied. So what is the key contribution over there? We done it with the semi-supervised learning, and we got an idea that this type of segmentation process or these type of segmentation can also be undertaken or can also be taken forwarded to any oncology based imaging technique or any oncology based imaging. That is what. The other one is we have reduced the false positives and false negatives over here, and this this gives us an idea of future IA innovation in oncology, radiology and dermatology. And then this lesions reduces the analysis time. Yes, given an image, it will segment it and provide you only the lesions out of the segmented images. This is what is the output of this one. We have done another paper. We have used the same set of data sets, which is I think that we have also included 2018-19 over here. So this is a powerful decision-making support system where we have not concentrated on the segmentation process. We directly did the classification process over there. But instead of using a supervised machine learning-based technology, what we did is we used a deep learning technology. Yes, so deep CNN have been used over here, and that CNN that we have used over here, or what we have did is the primary aim of this work is to undergo this work or is to classify these images with the help of the transfer models that has been coming under transfer learning technique. I hope that you have heard about this word transfer learning technique in the morning session itself. So what do you mean by transfer learning? Can you tell me what transfer learning is all about? Is fine-tuning the models, is first transferring the knowledge from one domain to another domain. So as we all know that all these big companies like Google, all these have released large amount of data sets, is large amount of image data sets. One such image data set is what is called to be an ImageNet database. So it consists of some billions of images that may be present in that data set. It is maybe common images most probably present, and few medical images may also be present in that data set. Yes. So transfer learning is a technique where what can be done is it can be classified with this transfer learning. What do you want? I want? No. Yes, the transfer learning has been technique where we can use this transfer learning technique. That is, the primary thing is I can work my model, this large model, which have been using this large databases, have provided you a better performance result for any classification that have been used. So the model has been built. So this model, which is not considered to be a simple model like what we are talking about the CNN. As I told you, the CNN may have simple layers like a convolution layer, activation function, followed by a max pooling layer, fully connected layer, and I have a softmax classifier attached to it. This is what is a one block of convolution layer. But all these big models will have different types of n number of blocks that have been attached, where these models will get, the complexity of the models will keep increasing over there, where it will provide you a better results over there, but it takes more computational factors, like the computing power is also needed over there, and it may work on large amount of data set. This is what is all about this large data set, and companies, big companies like Google have published better results with all these large data set. So what I can do is these model, I can make use of these models where I am not bothering about on which data set the models have been trained on. And the major important factor that what we are looking on for the deep learning model is all about the weights that I am going to. This one primary hyperparameter tuning that I can done. So whenever I go for any customized CNN model, what I need to do is I need to make use of my image, and I need to start it from the scratch, where I can initialize my weights and keep working on it and keep improving the model by adjusting the weights. Is one way that I can do, where I can spend a large amount of time over there. Instead of doing that one, I am very familiar, it has been very well proved that these models, the big models, can work, have provided a very better performance with the large data set. What I can do is, I can take the weights of this model, I can take the model itself, but whatever the model I have taken, the purpose of the intention of the model is different. It might be maybe the large data set what I am talking, it is maybe a common images that can be used, and it might be of different classes, of all about 1,000 classes that the model have been trained for. Yes, so what might be the final output layer? It may also, the output layer will have the nodes based upon the number of classes that I am going to classify. This is what is the softmax layer, probably layer will be doing that one. So what I am doing is, but I am using the big model, but I am very intended that I have to do for a binary classification. Only I want to say whether the image contains cancerous cells or not a cancerous cells. So what I will be doing, I will be adopting the model, remove all the final layers of that one. Yes, and I will be freezing, that is meaning freezing that I will fix the weights that have been trained by the model, the earlier by the different domain itself, and I will attach only my final layer. I will do some modification to my final layer, meaning that if it is maybe 1 or 2 layers, maybe where I can concatenate my feature vectors that have been obtained from it, and I can give my input to the final layers and try to get my output over there. So where my 1,000 number of classes now been cut down to 2 binary classes, where it can say it contains melanoma or non-melanoma over there. This is one property of a transfer learning. Another important thing is, what I can do is, I can extract one, I can remove my soft layer, the softmax layer, which has been at the last layer over there. I extract the features, the fully connected layer, which has been presented a part of a convolution layer, where it will concatenate all the features and provide it as a 1D vector over there. So I will take my features, I'll use very efficient classifier, machine learning classifier like SPM, or I can use any other classifier, where I can the extractor features will be given to the classifier, and the classifier does the classification based upon how many classes I need over there. So what I am doing is, I am not trying to extract the features over there. The weights that have been used for extracting the features will have been used there, and my model have been fed with one test images will be provided from my input, and I will try to get a better classification result with this case. This is another type of, that is fine tuning the extracting the features from the transfer learning technique, or fine tuning the features is nothing but I am just fine tuning my final layer and try to get the output over it. It is one way of doing that one. The another one is the domain shift, meaning that I have done the transfer learning technique during training. I've used an MRI image. Now my input image is only a CT image, where I am saying it is a domain shift from one domain to another domain, or it have been trained for a text image, text information. Maybe I am using that, cannot give you better input, but different domain, meaning that different types of images, common images have been used for training. Now I am using a medical image. It is one domain shift over there. So this is also another type of transfer learning. The another one is what is called to be a self-supervised learning. We have heard about semi-supervised, supervised learning and unsupervised learning over there. The self-supervised learning is nothing but a semi-supervised learning where we have been provided with few data with the label and a large amount of data without no labels over there. So what I will be doing, I will be making use of this few data, try to learn it from the few data and try to label my unlabeled data such that the learning can be made out of both from the semi-supervised, both from the labeled and unlabeled data. It is what is said to be the self-supervised learning. So these are the 4 different transfer learning techniques that have been adapted in your image-based informations over there. So what we did in the second paper, we make use of the transfer learning technique. We have identified the information only from the image features. As I told you, the availability of the multimodal data transforms the AI or provides a more impact on the medical tech industry. So we thought that we go for a multimodal data. So we obtained not only the image features, the metadata information of the patients have also been obtained over there. So we have used this one and we have explored the 2 techniques. One is what is said to be the fine tuning. The other one is what is called to be the feature extraction. Yes. So for this one, the model that we have used is what is called to be efficient net B6. Yes. And we trained the same thing. We obtained the features from the different machine learning, deep learning technique, such as ResNet 50, 100, all variants of this and tested over that one. All these have not given a better result, but this one, the efficient net, which is considered to be highly efficient, where FLOP, that is floating point operator that have been used over here is very less. That is, it is computationally efficiency. And why I am calling it as a computational efficiency? Because in all case of my traditional models, such as CNN or anything, what I am talking about, or ResNet or whatever it might be, all these models, as I told you, we need a larger complex model in order to get a high accuracy whenever my large data set is considered to be complex or it considered to be very large. So the model has to be also be complex in order to extract the features over there. So in all these cases, I have to either increase my width, height, and also my resolution of my image sizes. We always not intended to say that my model will work only for this size of images. Most of the models will work only like that. That is, my input layer will always say my input layer will take 255 by cross 255 size of the images. I cannot go for larger size of the images. So whenever my input is very larger, what I can do is I can resize it so that my features have been reduced over there and I can provide it to the input. This is what is the traditional model will make use of it. But it is not so in case of your efficient net model, where it make use of a compounding scaling, where my width, height, and the resolution of the thing, 3 will be parallelly will be scaled on, and then it can be used in this efficient net model. And that is all about a different variant of efficient net model, starting from where I can say B0 is the base model, and then I have different versions like 1, 2, 3, and 4, and 6, and we have checked it with this one. Our B6 efficient net model have performed very well, both in case of my feature extraction. As I told you, I have this model where my features have been extracted. Yes, and then I have my contextual data over there. So this is an image feature and this is the demographic information of the patient. All this metadata information, all these have been coordinated over there and have been given to a fully connected layer. And this fully connected layer will try to where I have made modification at my last layer over there, and it try to classify it as whether it is a melanoma or a non-melanoma over there. So I have used my efficient net in order to extract the features over there. So this is all about this, this one type of experiment. Then another type of experiment, what we did is, in this case, as I told you, I have a classifier at the end. I have used a simple classifier, which is what is said to be LGBM classifier, which is what is called to be a light gradient model based classifier, light gradient based meshing classifier, which extracts all these features will be extracted. And this is what is a fully connected layer. All these features have been concatenated into 1D vector and it has been given to the classifier and it classifies melanoma or non-melanoma, where it have used a fine-tuning methodology, which is what is called to be feature extraction methodology here in order to classify do my classification. The next methodology what we have proposed is all about the fine-tuning methodology. As we know this fine-tuning methodology, I have this image is, and it has been given to the efficient net, and I have the contextual information where I am extracting features from the contextual information. Both have been concatenated and given to the FC over there. So I have a classifier that this has been acting as where I have changed only my last layer of this one, and this gives me melanoma or non-melanoma over there. So this provides a better results when compared to that of the other transfer learning technique that we have used, and we produced about 91% of AUC, that is area under curve. It is one methodology that have been used in the deep learning technique or machine learning in order to assess the performance of the metric. So this is purely based upon the ROC. ROC is receiver operator characteristics, which talks about how many true positives have been well classified and how many false positives have been wrongly classified. All these information will obtained by a graph based methodology by Geskas of a receiver area operator characteristics, and AUE is the area under curve over this receiver ROC, and we have achieved an accuracy of 0.9, this AUC ROC curve of 0.96 with the efficient net thing. Apart from it, we also have done some research on the optimizer. So the optimizer is the one which makes my performance to be improved one by means of some hypertuning over there. So we identified, we always used a relevance and activation function, or instead of that one, we have also used a range optimizer over there where it doesn't need any hypertuning, and this range optimizer have also contributed something to our accuracy over there. So this is what is said to be, and we have an improved accuracy when compared to any CNN models, traditional models that we have used. So this is what been done as a next work, where I can say the semi-supervised learning, which we have dealt in our first work, have now been replaced by a fully supervised learning model methodology, and we have used a deep learning network over here in order to do the classification based on the meta-learning technique. Yes, so this is what is our next work. And then whenever, as I told you, the one that we have discussed till now is all about the black box. I didn't tell you. I may able to tell you because I have done my experiments with the help of your models. So I am the person which I have chosen the model. So I am able to say how many layers may be present, what are the different layers that may be present in this one. And I am not able to tell you whether it is possible for me to say at which level of my layers, what type of characteristics have been extracted, what type of features have been extracted. So I can now say all my models are considered to be black box, but I am able to see there is a performance improvement, but I am not able to say what are the features that have been extracted because I am not the deciding authority for all these models. The models have been are learning the features directly from the images itself. So it needs a large amount of images in order to learn the features by itself. So that is what has been the lagging over there. So I am not able to prove, even though my model says this much of accuracy, I am not able to say which makes my model to give this much of accuracy. That is what is the question there. So this have been done, this black mark nature of this model have been replaced by means of some information, which is what is said to be the explainable AA, meaning that I need some explanation from my model itself, saying that what part of the features have been contributed for the particular improvement or particular classifications. The reason, I need a reason from where, which part of the image have contributed for this accuracy, or which part of the image have been classified as this classification, this one. So the another reason why I am going for an explainable AA, I can say I have obtained an accuracy, a better accuracy over there, but there might be due to the results of my bias, but it may consider to be a biased results also. So in order to diagnosis that which may lead to a incorrect or unfair diagnosis, so in order to avoid all these ones, we have done some work on the classification with the help of the explainable AA too. This where these enhances the transparency of your deep learning models, and ensures the reliability, fairness, and safety in the medical imaging. So it is one of the important factor to be considered. So we have done some part of explainable AI too. So what we have did is we all know that we can able to do classification either with the help of the CNN or with any of the transfer learning technique that we have already discussed. Any of the methodology can be taken into consideration and classification can be obtained over there. So what do we mean explainable? We have, I hope that this have been already be discussed in the last session itself. So what is an explainable? I need an explainability out of my image. Which part of the features have contributed to the particular classifications or classify particular thing over there. So what we did it for this one, we also again engaged with different types of architecture like Inception, ResNet. All these are considered to be the transfer learning technique, which follows the transfer learning technique. We have used all these one and we try to concatenate the features that have been extracted. We can call it as a feature fusion, where we try to concatenate the features that have been extracted from the different models. So whenever I say, because I don't have the control over the number of features to be extracted from each of the model, what are the features have been extracted from the model, I try to try to fusion all these features, stating that the one that have been missed out by one model can be captured, the features that have been given by the other model can capture the type of the images over there. So in considering that one, we try to fusion all these feature networks. Whenever we fuse out all the feature networks, the size of the feature networks will become very larger over there. So we applied some technique, which is what is said to be principal component analysis technique, which we have used it to reduce to do the dimensionality reduction, meaning that I'll find out the important features out of all 1,000 features. Maybe I may got some 5,000 features from all of this fusion. And then I try to find out the important features and where I can say it is what is called to be a feature selection technique. I have reduced the features and out of this one, I applied some fusion selection technique also in order to find out what are the major features or important features out of this one where I can contribute more for my performance. This is what been done as a classification part. As I told you, there is an extension of this one. I need some explainability for the features or which features have contributed to the classification accuracy. So we used something called LIME. LIME is one explainable AI, which can be expanded as local interpretable model agnostic explanations, where it can provide the explanation for the features that have been extracted. Yes. So how this LIME works? Yes. So as we do know that it goes to give the explanations, the explanation is all to be come out from the images as the features have been extracted from the images. What I did is this LIME does this, it takes this image, divides into simple segments of pixels, meaning that the segments that been or the clusters that have been formed will be from the similar pixels, or meaning which interrupts us to say that similar features will be considered as a clusters over there, and all these have been divided into small clusters, meaning each clusters may be a part of the image over there. So which we call it as a super pixels. So I have divided my images into several super pixels. Each super pixels contribute to some features of my images over there. So out of these super pixels, some have been masked out and some have been taken into considerations. Even it has been masked out, I can call this one, I have repeated this one multiple times, where I can create tributed images, which there is a loss of information from the pixels over there, or by the division of images into small super pixel, there may be some, since I have masked it out, I can call it as a tributed images over there. With the help of the tributed images, what I need to do is, I will again apply a classification algorithm, that is a classification model, that is a CNN, to the tributed images and find it out which part of the tributed images or which of the tributed images does the classification very perfectly. Yes. So only I have some super pixel information over there. Each of these pixels, I have masked out some of the images, and out of these images it has been given to the CNN, where my CNN try to classify out of the tributed images, where it is capable of doing the classification very accurately with the help of some super pixels, and it is not possible to do it. That's the same in the other super pixel, meaning whichever is not providing the classification result is not contributing anything to my classification accuracy. Only the one which is responding to my classification result is being contributing much to the classification accuracy. It is what is the meaning of the interpretation of this one. So it provides an important score to differentiate the regions based on the prediction changes. So whichever is considered to be the red, it can able to provide you in form of the colors. The whichever is considered to be the red or the bright areas, I can say there is a high impact on the prediction, and whichever has a low color or a blue color, I can say it has a low impact on the prediction, meaning that that region has contributed more, and then other region, the blue color region, have not contributed much for the classification accuracy or doesn't undergoes any thing over there. So this is what is one image is, and I have applied my lime all these one, and I found some part where I have a different ranges of red color. All these portions have contributed to the classification. These are the features that have been used for the classification. This is what is the proof. With the help of this proof, people, the medical experts, keep keep trusting on these type of medical AIs, where they can try to use it, or I can say the achievement is in case of your assisted what is that one? Surgery. What is that one? AA assisted surgery. That is one achievement where that can be used only by the medical experts. Yes. So this is what is called to be the explainable AA. And again, the last one is what is called to be the few shot learning. As I have started with this talk, I told this deep learning models requires a large amount of data. Yes, the class imbalance should not be there. In whichever the classes, maybe I have 10 million classes or 1,000 classes, all these classes should have a equal amount of data that might be present over there. So this few shot learning, so that is what is one disadvantage of this one. Because whenever I go for a deep learning technique, it is what is called to be a supervised learning, where all the data should be labeled. Yes. So making the data to be labeled, even in any of the common images also, it may be it requires a large amount of it requires a large cost. Yes, over there. So but in case of my medical images, that is producing a ground truth or creating a label for the medical images, cannot be done by a layman people. It has to be done with the help of the medical experts alone. So it requires a more experts has to be involved over there, and it is considered to be an expensive or time consuming process over there. So what people have decided is if each and every application needs large amount of data, then the usage of deep learning will come down. So they thought of trying to develop a model such that the model capable of doing any classification or prediction based upon the few images that have been provided with it. It is what is called to be the few shot learning. Yes, I may have n different classes. For each of these class, I am not going for some thousands or 10,000 images. For each of the shot classes, I will be making a model to train with few shots. Yes, it might be 3 images, 5 images, or 10 images, or 7 images. So if it is so, how the model is capable of learning things and how it makes out the classification, it is purely based upon something which is what is called the model not only generalize the features, it generalizes the features, and also it try to predict out the similarity and dissimilarity between the images. Yes. So if I have provided for the class 1, if I have provided 5 images, it learns out there are some similarity that is existing between the classes. And if I have some 5 images in my class 2, it finds out the differences between class 1 and class 2, learns to find out the differences between class 1 and class 2, and also try to learn the similarity that exists between the class 2 over here. So this is what is said to be the few shots. So this FSL, that is a few shot learning, mitigates the bias by learning a generalized representation and works very well for the minority classes also. Yes. So normally all these few shot learning algorithm make use of one network, which is what is said to be prototypical networks. The purpose of this network is to find out the similarity and dissimilarity, and to learn the similarity and dissimilarity with the representations or the embeddings that have been obtained from this model. So this this one where whenever I have classes over there, different classes over there, for each of the class, a prototype will be built for it, and the model have been trained with the prototype. Yes, stating that it finds the similarity within the prototype and finds the dissimilarity between between different prototypes. And each class have been provided with some support sets. I can say it is a K-shot learning. The shot is all about number of images that have been provided in order to learn the particular class. So a query sample is nothing but the test image that have been given. What happened? It extract the embeddings from this test image and find out the similarity score. Again, whenever I'm talking about the similarity score, I can either go with the Euclidean distance or with the cosine similarity. And this prototypical model make use of the Euclidean distance. So I have a large data set. I can say this one. I have a large data set where I have n number of classes presented, and each classes have different shots of example samples that may be present as a part of the class over there. And this prototypical network tries to extract the features embeddings and try to learn the similarity and dissimilarity that exists between the different shots of n classes that is present inside that one. Whenever a test image has been given, the embedding have been taken out or the embedding have been taken, and these embedding have been compared with the embeddings of each prototype that have been present there. Whichever has the shortest distance, then this class image or the query image belongs to the particular class. This is what is the ideology behind the prototypical network. Yes. So based upon this prototypical network classification, we have done a different approach, which is what is called to be the meta learning approach. Yes. In this case of this meta learning approach, where we'll be training, we don't have a single large data set. We'll have different images, meaning that it is not of different classes, images of different domain. For example, I have some few medical images, may have some common images, I may have some animal images or something like that. Different domains where I can first find out the common representations of the domains over there, and then I will make use of any learning technique which I can say it is highly transferable representations. I am just making out the representations of different domains, try to learn about the different domains. So whenever I obtain an input image, a query image over there, it will find out the embeddings and try to learn this embeddings and compare it with the similarity based on the different domains that are present in. So it undergoes two phases. One is what is said to be the meta training phase, where I am using the backbone of the transfer learning techniques over there in order to learn about the different embeddings that may be present on the different domains. And then I am using a meta training testing phase where I obtained a sample query image, embeddings have been obtained, and then I have used any similarity measures or distance based metrics over there in order to compare to which domain this particular image can belongs to. So this is what is said to be the meta training phase. So this overcomes the problem of large data set and different domains. So I can say the generalization representation is one of the main theme of your deep learning models, and this have been obtained or captured through this few-shot learning thing, where I have used the same data set ISIC 2018 and DREM 7PT data set in order to do this one. So this is all about this thing. So where we started with the semi-supervised, moved on to fully automated with the help of the deep learning model, and then we created a explainability for the actions that have been taken by the deep learning model, and then we also ended up with a few-shot learning for the same data sets that we have done the work in the earlier stage. So this is what. So I can clearly show you a picture how AI have been developed and how it can impact and how the revolutions have been taken place in the healthcare, starting from I am just showing it only for the medical imaging. And earlier I have discussed about different AIs that have been used or developed by different companies, where they will be using in different areas of the medical healthcare itself, where all these have been proved as examples or how AI has impacted the medical industries. Yes. So as a nature of all these one, I can say it is revolutioning the healthcare. It's powered the telemedicine and also virtual assistants and mobile health apps bring medical experts to the remote areas. So any remote person who is at the remote places can also get the assistance from this one. And you have the personalized treatment based on the genetic markers, and you have the models that found to be inexplainable, which overcomes the bias that have been retained by this one. And you have the patient data privacy and security can also be maintained by it. Yes, the last one, AI won't replace any of the experts. Yes, but doctors who use AI will replace those who don't. Yes, so that is what is how I can say I can prove that AI has transferred the medical, or I can say AI has a large impact in the medical industry. Yes, thank you. So any questions? Okay. Can be explainable A, B. We have different explainable AI tools, but I don't think that it will be hallucinated. It cannot do that one. Maybe it's that's supporting what I am saying. It's a supporting document saying that this is what has been obtained and this is by the features that contributing that one. That might be the thing that, so it won't affect the system. It needs to be connected. Network connection. Net connection.
We will have a brief demo session. After that, we will continue with the presentation of remaining two teams. And who is having the attendance sheet with? Okay, all have signed. Is there anyone who has not signed? Just pass on the sheet here.
Yes, this clip architecture. Sir, not moving. The screen is not moving. Yes. This is one generative model. As we already discussed, the generative model helps us to generate any modality that may be text or image or video can be generated with the help of the generative models. Normally, the generative models will work based upon the random noise or something like that. From the random noise, it will able to generate any images based upon the probability distributions or normalized probability distributions. With this, how this image can be generated. But this clip model is also considered to be one of the generative model. And the expansion of the clip is contrastive language image pre-training model. But the purpose of this clip is not to generate anything. But what it does it, whenever I give an image text pair, it finds out the relationship that exists between the image and the text pair. Meaning that if there is a caption that I have given an image and I have given a caption for the image. So I will train with an image text pair to the clip. The clip will find out, try. It has an encoder decoder model, but it needs to have two different encoders and two different decoders, because image is one modality and text is in another modality. It try to extract it make use of a image transformer model in order to extract the features from the images, and similarly it make use of another transformer architecture in order to extract the features from the text also. It gets both these embeddings, try to find out the similarity and dissimilarity that exists between the embeddings, and with the help of what we have discussed in the few-shot learning, a prototype network. So it tried to find out learn the contrastive learning. It is what is called to be the contrastive learning. It not only learns the similarity that exists between this one, it also try to find out the dissimilarity that exists between the image and the text pair, so that it provides a better generalization representations of the image and text pair. And with the help of the cosine similarity, I can say whether the particular text belongs to the image or whether the particular image belongs to the text. So it can find out the mapping between the image and text pair with the help of the relationship that exists between the image and text pair encodings that have been present there. So I now say this clip as a contrastive language image pre-training model. Yes, so moving on to this architecture, this is one which have been used in your DALI. DALI make use of this one. DALI is the one famous image generative model. It generates very high pixelated images. Yes, all these pixelated images have been generated with the help of this clip. Clip have been used as a basic thing that were over there. So we have seen different scenarios. Given a text, an image can be generated. Given an image, a text can be generated for the images. Text means a description of the text can be generated from the images. All these all these image generation model make use of this clip technique. Yes, it uses the clip. It finds out the relationship mapping between the image and text embeddings, and from these text embeddings, it will find it out. It will try to generate all these ones. As I told you, this is a contrastive learning where it doesn't learns only the similarity, it also learns the dissimilar one. Given an monkey, if I have provided another monkey which is of a different environment, it tries to find out the similarity to extract the features of this one, extract the features of this one. Maybe the environment, a background may be different, but the features of my monkeys will be the same over there. So it finds out the similarity over there. Apart from it, it also tries to distinguish the monkey from different classes. So it finds out the dissimilarity that exists between these images and try to learn out the similarity and dissimilarity from both these things. Yes, it can be image pair, image text pair, and text pair can also be done over there. So the purpose of my contrastive learning is to learn the similarity and dissimilarity that exists between the modalities that have been given as the input there. So it makes use of two architecture. One is the encoder architecture, the other one is the decoder architecture. The purpose of the encoder architecture to extract the features or the embeddings from this one, and it should have a, what I can say, it might be a contrastive representation of the features that may be present in the image. As I have two different modalities, I will be giving the input as an image text pair over there. So I have to learn the embeddings of the image and also learn the embeddings of the text. So this will use as a dual encoder. For the image, it may be using a vision transformer, where the vision transformer of this image encoder may have a simple transfer learning technique that may be used over there. A CNN based architecture may be the part of this one. So we all know that all these CNN based architecture helps us to extract the features from the images that have been given. So it will extract the features from it. I now call these features as an embeddings of the image. And similarly, I have a text encoder where I can use an NLP technique, where I can use another transformer based model like BERT or something like that, where I can extract the embeddings from the text also. So with the help of these two embeddings, it can be able to make out the similarity that learn the similarity that have been present in both these embeddings. So we put up in a common space, which is why we call it as a shared embedding space. The two embeddings from these encoders have been put up in the shared vector space, and these allows the clip to compare the text and image representations and also try to learn or understand the relationship that exists between these two things. So that only if I am providing an text saying that I need to say I want to have the pictures of a cat, white and brown color cat, I may get a pictures of white and brown color cat from this one. The text have been given, so it can able to generate that part of this one over there. So this is one thing, and then this is the simple architecture of the clip. As I told you, I will be giving not only the image or not only the text, I will be giving text image pair. So it is all about the text is nothing but the description of the image. It is all about the puppy, the pepper, the assy puppy is what is the description of the puppy. It will be given to the image encoder and this text will be given to the text encoder. All these encodings have been put up in the space where it will learn about the general representations or relationship that exists between these two things. So whenever I do this one, I will not provide you the image text pair which are a genuine text pair. I will try to also provide some image text pair because it is a contrastive learning. It learns not only similarity, it also try to learn how the dissimilarity that exists between them. So I also provide some mismatched information into it, where I can able to, that clip can able to learn both the similarity and dissimilarity by means of the contrast embedding over there. So it creates this shared latent embedding. That is what is the one first process of clip. After this one, what it will does is, it have the image. So for all the images, I may have the labels. Labels are nothing but the description of the images. So for each one images, all the labels will be given to it. It will extract the encodings, and again for each image, each against the labels, it will find out the dissimilars, which is the proper description can be considered to be the dissimilar between the similarity between the text and the image. It will learn to it, and also it identifies the dissimilarity that exists between them by providing an image with multiple labels to the image also. That type of learning. So it create a data set classifier from the label text like this. So now it can able to pair single image with text, and also I have given single image with no matching text, and also I have provided an image with n number of labels, where few labels are the description of the image and few are not the descriptions of the image. All these have been learnt over there. So what happens after this one? I'll be providing with a query image, or I can call it as a query image over there. So the query image is what is called to be the test image. So I will get the embeddings from the text image and try to find it out. The similarity indexes or the distance similarity measures can be used, like a cosine similarity index have been used in your clip architecture, where it find out the best similar embeddings out of this what I have learned from the data set. So with the help of that best similar embeddings, it provides you the label for the provided input over there. So given an image, it will provide me the description of the image from whatever it have been learned through the contrastive learning. This is what is said to be the clip architecture. Yes. So which have been done here is what is called to be zero shot prediction, because it has not been known to the training. It has been not been shown to the training over there. It has to be predict with the single shot over there. So I am calling it as a zero shot prediction over here. So this is how this clip works here. And for this one, I will show you the demo in what are the different ways. So this part of this one, this I have doing it in a Colab, which is an online compiler where I can run all my deep learning models here in the Colab environment. Yes, you can get a username and password from this one, and these GPUs are free for you. Yes, and you can use and train your GPUs here in this one. So the first process is I have uploaded some images. I have uploaded 8 images in my drive there, and I will also have a corresponding label for this one. I'll try to learn the embeddings from this one, from both the image and the text with the help of the clip. I'm uploaded my images in my drive, so it is trying to mount the drive. And this clip have been developed by the OpenAI. So this part of the code helps me to get this clip which have been present in the, it's not getting mounted. So this part where I am downloading my clip which is present in the GitHub, and I am using this pip to install the OpenIA and the clip that have been that Git that have been present in the GitHub here. In this repository, it has been present. I'm trying to learn this one. If I try to learn this one, it takes all these requirements that has been satisfied that needs to run this one, the torch version, packages, all the packages, all these one can be downloaded. And all these one which has been used for running the GPU will be downloaded here. Yes, once I have done with this one, I can go for this one. I am just importing the clip. I have taken it from the GitHub. I am importing this clip. And you have different models of clip available. The different, as I told you, this vision transformer model can be used in your clip image encoder. And you have a BERT or a BBERT can be used in your image text encoder. So all these available clip models will be listed here. Yes, so this is what are the different available clip models. This RNN, all these RNNs can be called for the used for the image, and this VITs, all these VITs can be used for the visual transformer models have been used for the text over here. Once it have been done this one, I am trying to load one particular VI, vision transformer model 32 here, and then I am just setting out the parameters. That is what is the size of the image that I need to take in, and what is the image resolution, and I have to define, because I have to extract the embeddings. So I have to fix out what is the size of the embeddings. So it is what is said to be the context length. Yes. And then this is what is the model parameters. So this model is capable of getting 151, 277, and this is what is the model parameters, and the input resolution is 224. Context length I have fixed it to 77 for the image, and this is what is the vocabulary size of all these inputs. Once I have done this one, what I am trying to do is I'll read each of my input from my content from my drive and apply some pre-processing such as resizing. I am doing center cropping where I can extract the size of this 254 from starting from the middle of my image, and then I am converting it to tensors, and then this tensors, and I am just finding out the mean, normalize the image to some mean value there, to normalized value here. So I have done some pre-processing for the image. After pre-processing this image, where I have extracted the features of the image, then I need to go for my text information. I need to tokenize the text, and also text is nothing but the corresponding corresponding descriptions of the image. So it has to be extracted, and the feature embeddings has to be extracted from this one. And again, as I fixed the size of the clip is capable of using 77 length size of my image vector, my text vector is also up to be 77. My description will not be of 77 size. So for example, I have just given notated you with one simple example. If I am saying, I am giving it to the tokenizer saying that hello world with all this double quotes and apostrophes, what it happens is, it is what is the embeddings that I have obtained, and for all the other things I have made it at 0, because I need a 77 length vectors out of this feature vectors out of my text too. Yes, so both these embeddings should be of a variable, not to be a variable size, it should be of the same size. So once I have done this one, what I am doing, this is what is the descriptions. I told you that I have taken 8 images. For 8 of these images, this is might be the name of the images that I have stored, and for each name of the image, for the name, I have given a text, a page of text about segmentation. It is what is one input, that is a one paper with some content has been there in the image. This is the description of this one. And I have a motorcycle, right? A red motorcycle standing in a garage is the description of this image. And a camera, a person looking at a camera, and a tripod is a description of this image. So this is what is the description of each of these images. So as I told you, I will be using an image encoder and a text encoder. I will get the embeddings and fix the variable length of both these embeddings to a 77 size over here. Okay, once I have done this one, and I have used this. This is what it's not running. It has to run, I think. Okay. So once I have done this one, I have done a plotting of this one. I have find out the cosine similarity between the image and the text features. The cosine similarity is nothing but the dot product between these two feature extractions. So I did that one and find out the cosine similarity. So whichever images have the maximum similarity, whichever descriptions have been matched to whichever image, then the image text pair will be displayed, and this part of the code will help me to plot image along with the text pair. Yes. So the first one is I want to find out to image similarity. This is what is the next one. As I told you, I can have image text as my input. And now I want to find out the image to image similarity. This is another approach. This can also be done. It extracts the embeddings from the first image and extract the embeddings from the next image. Based on the cosine similarity, it will say what is the similarity between these two images. What is this approach? Yes. So this is what. So I am just pairing it out. I have that images in the content drive, in my Google Drive, and this descriptions have been given here. I found the similarity also. I am just pairing the image text pair here. So this is what is my input, and this is what is my another input, that is the text input corresponding for the image over here. So the next one, I need to find out the similarity. Sorry. So this is what is this image encoders, and this is what is the text encoding. This what we have described there, where it is a function where I am calling the functions, passing the image to get the encodings of the image, and also the text to get the encodings of the text here. So I am calculating the similarity. So if I am calculating the similarity, it will display what is the similarity between the image and the text. It displays the cosine similarity between the ith image with the jth image. Sorry, ith text with the jth image. Yes. Yes. So it takes each and every image and compares with the cosine similarity of all the texts, texts that have been given, 8 texts I have given, and finds the cosine similarity of all the texts that I have provided, and we find the more similarity value only for the image text pair, corresponding image text pair. So when you look onto this one, this horse, a black and white silhouette of a horse, this is what is having the highest similarity measure when compared to all other similarity, cosine similarity of all other image, text and pair. So this one, here I am just collecting the data from the CIFAR. CIFAR is a common database where it contains the image and the corresponding labels. It has a common database where large number of labeled images have been present there. I have different classes like woman, girl, and motorcycles, cars are similar to that of what common images, and different labels of these images will also be present there. What I am trying to do is, I am trying to get each of the images and the corresponding classes can be taken as a description over it. So, and I am just comparing it with this image, 8 images. And what I will be doing is I am getting the embeddings and try to find out the similarity between the embeddings. I'll classify this class to the corresponding labels. That is what I am trying to do here. As I told, CIFAR consists of different things. I am just downloading the CIFAR data, and then for all these data, the description is nothing but the labels that have been given. Yes. So I am just extracting I am just tokenizing this description of the labels, and then I am finding the similarity between these labels and my 8 images. So I can say to which class the corresponding images can fall on. Yes, see here, there are different classes that have been present in the CIFAR. One is the girl class, boy class, racket class, plane class. Out of these classes, this woman, this astronaut, has a greater cosine similarity, a larger cosine similarity to the girl class. Yes. So how it does it? It gets the similarity of my labels. Compare the cosine similarity between the embeddings of the particular images and these class labels. Yes, and it plots it to which class it belongs to. So the highest cosine similarity is between the label and the girl and the astronaut picture. And similarly, I have a camels class where this horse have been mapped to this camel class, and you have something called this one. This is considered as a keyboard, and this has the highest similarity score between this one, the content and the keyboard. And then bike, motorcycle, yes, it has the highest similarity. And then this cat have been recognized as a tiger. So it is purely based on the embeddings that have been extracted from this image and the labels of my CIFAR data set. So for both these the cosine similarity have been mapped, and to that one, the corresponding images have been classified, can be considered as a classified class. And this one is image to image similarity score. This is similar to that one. Given 2 images, I can find out the embeddings of the 2 images, find out the cosine similarity between the 2 images. This can be considered as the base to generate an image if a given an image and text pair have been given for the training. So I am just trying out to find out the similarity between rocket and coffee, and also a cat and Tesla. So these 2 are considered to be 2 different images. Their similarity will be very less. And these 2 are considered to be same family images. So their similarity will be more over there. Yes. So cat, Tesla. This is the one which has the highest similarity of 0.721. And the other one, the rocket and the teacup, has a lowest similarity of 0.48. Yes. So this will extract the embeddings from either from the image or from the text, and it's able to find out the relationship that exists between them with the help of the cosine similarity of the values of your embeddings. Yes. So this is used as a base architecture in your DALI. DALI is the one that has been considered to be very efficient image generation tool. Yes. So this is the one that can generate the this have been used. This architecture is a part of a DALI architecture, and I have an enhanced. After this one, I have many different architecture that help me to generate the images. It helps me to find out the relationship between the given text image paths. Yes. So if instead of using a CNN architecture, you can use this clip architecture itself. We can have the training images labels with the images over there. So you can use the similarity measures to find out the test image to which thing it belongs to. This can be reshaped with phased with the CNN architecture. You can check it out, how the classification accuracy is, whether it is improving or not improving. Okay, thank you.
Thank you, ma'am. As a token of our gratitude, I now kindly request Dr. Gopika, Coordinator, ATAL FDP, to offer a memento and certificate to Dr. P. Mrinalini. Once again, thank you, ma'am, for that enlightening session on impact of AI in medical industry. It was really interesting and insightful. I now request all participants to join for the group photo.